Welcome to this Generative AI mini course. First, we will understand the Gen AI fundamentals. Then we will learn Langchain, which is a Python framework used for building Gen AI application. And in the end, we will build two end-to-end Gen AI projects. The first project will be using commercial GPT model, where we will build equity news research tool. The second project will be using open source LLM model, where we will build a Q&A tool in retail industry. Let's start with the definition of Gen AI. AI can be categorized into two sections: generative AI and non-generative AI. When you talk about non-generative AI, you are dealing with problems such as you have a chest x-ray and you want to find out if this person has pneumonia or not. Or maybe you have some data on person's credit history and you want to figure out if the person should be given a loan or not. In these problems, you are not creating new content. You have data, and based on that data, you are making certain decisions. In the case of generative AI, however, you are generating new content. The classical example is ChatGPT. ChatGPT is a Gen AI application. Here you can write your resume, you can plan your trip, you can even create an image of Hulk playing Gujarati Dandiya. In summary, generative AI is a category of AI that is associated with generating new content, and this new content can be text, images, video, audio, etc. Let's now look at the evolution of Gen AI. In the early days of AI, the kind of problems that we used to solve was predicting home price based on factors such as the area, the bedrooms, the age, etc. This is called statistical machine learning, and the factors which determine the price of the home, such as area, bedroom, age, etc., they were called features. Now, these were simple features. When it comes to image recognition, such as identifying if the image is cat or dog, the feature was kind of complex. See, here the features are the whiskers or the pointy ears that the cat has, and this data, which is an image data, is just a bunch of pixels. So it is unstructured data. In the case of house price prediction, you have structured data, area, bedroom, etc. So therefore, these features in an image, they are called complex features. The cat's face could be in a different angle, and this ear can be in, let's say, in this corner, or let's say the legs are not present at all. So that makes image detection problem much complex, and sometimes you can't use statistical ML for this. Therefore, neural networks were invented, and that gave birth to deep learning. So there was a statistical machine learning before, then came deep learning, where neural networks was the main approach that we used. After that came recurrent neural network. So in recurrent neural network, what you have is this kind of network, and let's say you are trying to translate this particular sentence in a different language. Let's say you want to translate from English to Hindi. What you do is you feed the first word to a neural network. So I will feed Dhaval to a neural network and it will give me this translation. This A1 is nothing but the translation of Dhaval in, let's say, Hindi. After that, you feed the second word and the translation of previous word to the same network. So these are not four different networks, okay? This is just a time axis. It's the same network where you feed the translation of the previous word or previous sentence. So that created a kind of a loop within the neural network, and it is called recurrent neural network. This was used for solving problems like language translation. And then came more sophisticated problem, which was kind of generative in nature. So here is the email which I got, and in Gmail, when I try to respond, it will try to autocomplete. You just notice that when I say, thanks for reaching out, here's my availability, see, it is auto-completing all these words. And the way it works is it looks at the content of the email. So let's say Angela said, hey, we have a potential collaboration opportunity. Do you have time to talk? So the network will read this sentence, and then it will try to predict the probability of the next word. So when I'm saying, Angela, thanks for, the probability of saying contacting me is higher. And probability is generally between 0 and 1. Let's say contacting me has a probability of 0.91. I can also say thanks for reaching out, and probability of that could be higher. I can say thanks for finishing the project, but In the context of the previous email that Angela sent me, the probability of this might be lower. I'm putting these numbers randomly, but you get an idea. If Angela had said that, hey Dhaval, I have finished the project, please check it out. In that case, I can say, Angela, thanks for finishing the project. So if we had that kind of context, then the probability here would be higher. But since we're talking about the collaboration, the probability of finishing the project is lower. So you get an idea here. If you parse huge corpus of text and try to build a language understanding, you will be able to predict the next word that comes in the sentence, and this is called language model. It is an AI model that can predict the next word or set of words for a given sequence of words. So here I have text from Wikipedia, okay, and just look at it. This is the Wikipedia article on India's freedom movement, and here, to train the neural network, we can create the training pairs from this paragraph. We can come up with a problem that we want to solve, and the problem is filling the missing word. So here I am saying first Indian nationalist. So first Indian nationalist to embrace, okay. So what is the missing word here? Well, nationalist. Similarly, we can come up with this kind of training pairs, and then we give these training pairs to neural network for training, okay. And this approach of training a neural network is called self-supervised learning. So the good point here is that when you want to train a language model, you don't need a lot of labeled data. You can take Wikipedia text from news articles, text from variety of books, and generate these training pairs and then train the neural network. And after that, neural network will be able to predict the missing word or the word that comes next in the sentence, just like how Gmail autocomplete is working. And when you feed huge amount of data to this neural network, and let's say when you have so many layers in the neural network, let's say that neural network is big, what we get is large language model. GPT-4, a model behind ChatGPT, is a large language model. It has 175 billion parameters. And when I say parameters, is nothing but all these weights in the neural network. So see, this neural network has only 10 parameters. Imagine a huge network with so many layers having 175 billion parameters. The critical breakthrough in Gen AI came when this particular paper called Attention is All You Need was published, which gave rise to a spatial neural network architecture called transformer. So just to summarize, previously we had statistical machine learning, then came deep learning, which was based on neural network, then came recurrent neural network, and then came transformers, which is very powerful. And talking about transformers, we have variety of architectures or variety of models. For example, Google has this model called BERT. OpenAI came up with this model called GPT. If you look at your ChatGPT application, you will find this model right now. It's GPT-4. So that is the model that they use, and it's called Generative Pre-trained Transformer. That's a long form of GPT. Similar to text model, we have image models too. For example, DALL-E, Stable Diffusion, etc. This is the image generated by a model called Stable Diffusion, and if you have a ChatGPT Pro version, you can generate image. For example, generating an image of a person selling vada pav on Mars. Look at this image. I mean, it is quite better. I know this person is not wearing the mask, but still it's doing a pretty decent job. To summarize, we have text-to-text models such as BERT GPT. We have text-to-image models such as DALL-E, Stable Diffusion, where you give text and it generates image. And OpenAI Sora is an example of text to a video model. You can just Google OpenAI Sora, you will find the demo. You can give a text prompt and it will generate an entire video out of it. So all of this has become possible because of transformer architecture. And now that you have good understanding of variety of models in Gen AI space, let's look at an analogy based understanding of LLM. What I'm trying to do here is clarify all these concepts such as LLM, vector DB, etc., because these concepts are used heavily in the field of Gen AI. Okay, so next I'm going to play an analogy based animated video of LLM. Peter Pandey has a curious parrot called Buddy. Buddy has a great mimicking ability and a sharp memory. Buddy listens to all the conversations in Peter's home and can mimic them very accurately. Now when he hears, "Feeling hungry, I would like to have some biryani." For this case, the probability of him saying biryani, cherries or food is much higher than the words such as bicycle or book. Buddy doesn't understand the meaning of biryani or food or cherries the way humans do. All he's doing is using statistical probability along with some randomness to predict the next word or set of words purely based on the past conversations he has listened to. We can call Buddy a stochastic parrot. Stochastic means a system that is characterized by randomness or probability. A language model is somewhat like a stochastic parrot. They are computer programs that use a technology called neural networks to predict the next set of words for a sentence. For a simple explanation of a neural network, please watch this particular video. Just like how Buddy is trained on Peter's home conversations dataset, you can have a language model that is trained on, for example, all movie-related articles from Wikipedia, and it will be able to predict the next set of words for a movie-related sentence. Gmail autocomplete is one of the many applications that uses a language model underneath. Now that we have some understanding of a language model, let's understand what the heck is a large language model. Let's go back to our Buddy example. Our Buddy got some divine superpower and now he can listen to Peter's neighbors' conversations that are happening in schools and universities in the town. In fact, not only in his town, but all the towns across the world. With this extra power and knowledge, now Buddy can complete the next set of words on a history subject, give you a nutrition advice, or even write a poem. Like our powerful parrot Buddy, large language models are trained on a huge volume of data such as Wikipedia articles, Google News articles, online books, and so on. If you look inside the LLM, you will find a neural network containing trillions of parameters that can capture more complex patterns and nuances in a language. ChatGPT is an application that uses LLM called GPT-3 or GPT-4 behind the scenes. Other examples of LLMs are Palm 2 by Google and Llama by Meta. On top of statistical predictions, LLM uses another approach called reinforcement learning with human feedback, RLHF. Let's understand this once again with Buddy. One day Peter was having a conversation with his cute little 2-year-old son. "Son, don't eat too much bananas, else Hearing this, Peter realized that Buddy has been listening to the conversations from abusive parents in his town. What he said was the effect of that. Peter then starts keeping a close eye on what Buddy is saying. For a same question, Buddy can produce multiple answers, and all Peter has to do is tell him which one is toxic and which one is not. After this training, Buddy doesn't use any toxic language. While training ChatGPT, OpenAI used a similar approach of human intervention, RLHF. OpenAI used a huge workforce of humans to make ChatGPT less toxic. While LLMs are very powerful, they don't have any subjective experience, emotions, or consciousness that we as humans have. LLMs work purely based on the data that they have been trained on. Now that you have some understanding of LLM, let's cover two other important topics called embeddings and vector database. Embedding is nothing but a numeric representation of text in form of a vector such that you can capture the meaning of that text. Once you create embeddings for a given text, you can do math with the words and sentences such as Paris minus France plus India equal to Delhi, or Apple minus Tim Cook plus Satya Nadella equal to Microsoft. This sounds crazy, right? But it is actually possible due to embeddings. And vector database allows to store these embeddings and perform efficient search on these embeddings. So let's try to understand these concepts in a bit more detail. We'll start first with the startup boom that is going on in the field of vector databases. There are some AI startups that have raised millions of dollars of funding, and they have one product in common, which is vector database. Let's try to understand what exactly is vector database today. When you search in Google calories in apple versus employees in Apple, Google figures out that the first apple means fruit and the second one is a company. Have you ever wondered how does Google does this? It uses a technique called semantic search. Semantic search means not searching using the exact keyword matching, but understanding the intent of a user query and using the context to perform the search. For doing semantic search, internally it uses the concept of embedding. Word embedding or sentence embedding is nothing but a numerical representation of text. Let's first understand how exactly embedding works. Let's figure out how you can represent this word apple into a numeric presentation given this particular context. One way is to think about different features or properties of words. Here you can have related to phones, easy location, has stock, etc. as properties, and then you assign value for each of these properties. Revenue here means $82 billion. You get a sequence of numbers as a result, and that is nothing but a vector. So this vector is a word embedding for the word apple for this particular context. If you're talking about apple, the fruit, then the embedding might look something different because the value of these properties is different. And when you have the embeddings for different words, looking at the embedding, you can say that the second apple and the word orange, they are similar because look at their values, they're matching. Of course, there are some values which are not matching, but compared to this vector and the first vector, second and third vector are kind of similar. Same way, if you have, let's say, Samsung as a word, you can represent that into a numeric presentation. Is it related to phones? Yes. Is it a location? No. And when you look at, again, all these vectors, you can figure out that the first and the fourth vectors are kind of similar. So using these vectors, you can figure out the similarity. Not just similarity, you can actually do a complex arithmetic such as this. This is a famous example in the NLP domain where you can perform this mathematics using a technique called word-to-vec. Word-to-vec is a technique to represent word into a numeric representation. I have made a separate video, so if you want to know more about it, you can go and look at this video. In that video, I have explained how you can generate handcrafted features for each of these, and you can do this particular math. Now, just for intuition, I explained everything using handcrafted features, but in reality, you use some complex statistical techniques to generate these word embeddings. Again, if you have curiosity, you can watch those two videos or this particular video on BERT. So far, let's say you have this understanding that there are a variety of these techniques that you can use to represent a word or a sentence or even a document into an embedding. And here are just different techniques which are being used. In ChatGPT era, obviously transformer-based embedding techniques are getting popular. So when you're using OpenAI API for embedding, you know what technique it is using underneath. When you are building any text-based AI application, you might have thousands or even millions of embedding vectors, and you need to store them somewhere. When you think about storing them, the first option that comes to mind is a traditional relational database. So let's say for our use case, we have these 4 articles. The first 2 read are related to Apple the fruit. The remaining are Apple the company. You will first generate the embedding, let's say using OpenAI API, and then you will save that into, let's say, your SQL database. Now, when you have a search query, you will also generate embedding for that, and you will try to compare this embedding with the stored embedding and try to retrieve the relevant documents. Here, you will use a concept of cosine similarity to retrieve the matching vectors, and you can display it in your Google search result. This in theory works okay, but in reality, you will have millions of records or even billions of records in your database.
And that's when things starts getting interesting, because just think about matching this vector. For a query vector, if you want to match with these stored vectors, then one of the approach you can use is linear search, where you go one by one, and if cosine similarity is close to 1, then you will put that vector into your result data set, and then you can keep on going and store your result vectors. Now you already realize the problem. If there are millions of stored vector embeddings, your computation is going to be too much. Your hairs will be raised, because you can't handle delay and computational requirements for such a use case. You need to do something smart. How do we do this in a traditional database? Well, we use a thing called index. Database index helps you search things faster. Similarly, in this particular use case, we can use one hashing function. We don't need to go into detail what that hashing function is, but let's say this hashing function is creating buckets of similar looking embeddings, okay? And then when you have a search query, you can let that go through the same hashing function, which will bucket it into one of these 3 buckets, and then within that bucket you can do individual linear search. This way you are only matching with those vectors which are in bucket 1. You don't have to match it with bucket 2 and bucket 3. This will speed things up, and this technique is called locality sensitive hashing. This is one of the techniques that vector databases is using. There are many such techniques, and those techniques are outlined in this beautifully written article. I'll provide a link to this article. You can read through it. So far you have realized that vector databases help you do faster search. They also help you store things in an optimal way. So these are the 2 big benefits why vector databases are gaining popularity. After databases, we need to understand the concept of retrieval augmented generation, also known as RAG. In my company, Atlic Technologies, where we work on multiple AI client projects, one of the common requirements is we have this private organizational data, or we have this public custom data set. Can we fine tune ChatGPT on this, or can we build ChatGPT like solution on this specific data set? And the way you can do that is by using RAG. Let me explain this by giving you an analogy. Let's say you have a college student called Mira. Mira is a very smart individual. She is generally good with things. She is studying in computer science. Now we want her to appear in some competitive biology exam, which will be based on this book called How Microbes Rule the World. The idea here is to not make Mira a biologist, but she should just go and appear in that competitive exam and win the prize. Now you can do this thing in 2 ways. Option 1 is full-fledged training, where she goes to a college, attends biology classes for 1 entire year and becomes expert in biology. Option number 2 is, if the exam committee is allowing open book exam, Mira can take this book with her. You might be aware about open book exam concept, where you can take a book in the examination and you can refer to the book to write the answer. Which option will you go for? Obviously option number 2, because you will save time and money both. Mira doesn't have to wait for 1 entire year to finish her biology studies. Instead, she will take this book, and since she is very good in terms of reading, writing, and generally she is very smart, so she can quickly figure out the answers and she can write those answers during the exam. Similar to this approach, when you are building RAG based Gen AI application, what you do is you take question from a user, and the LLM or the large language model will refer to our database. Now this database could be Excel files, PDF documents, SQL database, anything. This could be either your private internal organizational data, or it could be a public data. The idea is you want LLM to pull the answer from this particular data sources, and LLM can do that using this concept called RAG. Okay, we will go over technical understanding of RAG when we do our end-to-end project later on in this video, but let's first look at the tools that we can use for building Gen AI applications. ChatGPT is a Gen AI application, okay, which uses GPT-4 as a large language model. Now this AI model is similar to human brain, which is trained. See, if I look at my brain, it has been trained through my experiences, through the college studies, through the books that I have read, etc. GPT-4 is a similar model that is trained on your Wikipedia articles, books, and so much of that data. Now, having brain alone is not enough. You need a body, correct? So I have this brain, but if you want to get benefit of the knowledge in this brain, you need this body, like these eyes, this voice, which can interact and solve a variety of problems. Similar to that, GPT-4 model is just like a human brain. You need body around it, and that body is nothing but a backend server. If you have done software engineering, you might be aware about these web servers, which are based on Node.js, Django, Fast API, etc. So you build this kind of a server. Now, when you're using ChatGPT application, the server runs in OpenAI cloud. But let's say tomorrow you want to build your own application. Let's say this kind of database Q&A system for a retail store, where you ask a question and it will pull the answer from your internal private database. We are going to build this tool, by the way, later on, okay? So stay tuned. But here, this UI or the front end will be making a call to a backend server, which can be using this GPT-4 model, and it will use Retrieval Augmented Generation RAG to pull the answer from MySQL database. We will see when we do that project how exactly this is done, but I'm just giving you an overview right now. So the answer that you're looking for, that how much total price of inventory for small size t-shirt, this answer is available in this database, and GPT-4 is converting your question into SQL query, and it is pulling the answer. And you can deploy this backend server into Azure cloud. Azure has this service called Azure OpenAI service, where you can host your private GPT-4 model so that your data is protected, it doesn't go out. If you don't want to use Azure, you can use things like Amazon Bedrock. Now, Amazon Bedrock doesn't have GPT model, but it has other foundational models such as Claude, and I think it has this model called Llama 2, Mistral, Stable Diffusion. It has so many models. So to summarize, there are commercial models such as GPT, Gemini, etc. But there are open source models such as Mistral, Llama, etc. Now, let's say you build your application using GPT model, and tomorrow you're not able to afford the GPT-4 bill because they charge per token, okay? And let's say you want to save your costs. What do? Well, you use open source model such as Llama 2. So in this case, you might have built time to develop this code. Let's say you have 20,000 lines of code, and now you have to redo all these things. Wouldn't it be nice if we have some way where you write an application, you write some code, and you plug your GPT-4 model, and tomorrow if you can't afford the bill, you plug a different model. Okay, so that way is Langchain. Langchain is a Python framework that is used to build Gen AI applications, and it's a very popular framework nowadays. So if you are building Gen AI application, you'll have to learn this framework because that makes building LLM apps easier. To summarize the tooling for Gen AI, first thing you need is some model, some LLM model. It can be a commercial model such as GPT-4 or open source models such as Llama or Mistral. It can be image models as well. Then you need cloud service. So you can use Azure OpenAI, Amazon Bedrock, Google Cloud. There are so many cloud options that you have. And then you need framework like Langchain. You can also use Hugging Face Transformer library to use a variety of open source model. And then in terms of deep learning libraries, you can use PyTorch, TensorFlow, etc. Now is the time that we learn about Langchain framework. So I had this other Langchain crash course on my YouTube channel. in which I went through the Langchain framework. So I'm just going to play that now. It is a crash course on Langchain. All right, so let's get started with Langchain now. Langchain is a framework that allows you to build applications on top of LLM or large language model. In this crash course video, we are going to go over all the basics of Langchain, and then we will build a restaurant idea generator application using Streamlit, where you can input any cuisine, Indian, Mexican, etc., and it will generate a fancy restaurant name along with the menu items. First, let us understand what is Langchain and what kind of problem does it address. When you are using ChatGPT as an application, internally it is making call to OpenAI API, which internally uses any LLM such as GPT 3.5 or 4. In this case, ChatGPT itself is not an LLM, it is an application. Whereas GPT 3.5, 4, these are large language models. Now let's say you want to build an application for restaurant idea generator where you give a cuisine and then it will generate a fancy name such as Taco Temptation for Mexican and menu items as well. Let's say you give Indian cuisine, it will say, okay, curry Palace or Sahara Palace for Arabic along with these menu items. So this is a sample application which we are going to build, but this is an LLM based application. And for this, we can use the same architecture as ChatGPT, where we can directly call OpenAI API. And here I have provided a screenshot of their main API. So you can call it and you can get a behavior similar to ChatGPT. Internally, it will use GPT 3.5 or GPT 4 model. In this case, once again, Restaurant Idea Generator is an application similar to ChatGPT, but internally you are using OpenAI API and the LLMs. Now, there are a couple of limitations of following this approach. And by the way, the reason I'm telling you this is nowadays there is a big boom in the industry where every business wants to build their own LLM. You would think why they can't use ChatGPT, because ChatGPT has no access to your internal organization data. So people want to build applications which are based on LLM. Okay, so there is a clear demand and clear boom in the industry for this. And why do business not use this kind of architecture? Well, there are a couple of things to consider. First of all, calling OpenAI API has a cost associated with it. For every 1,000 token, they will charge $0.002 or something. You can check OpenAI pricing page, but there is a cost associated with it. And if you're a startup who is having funding issues and your budget is limited, this is going to be a bottleneck for you. Another thing is, you might have noticed ChatGPT doesn't answer latest question. Its knowledge is limited to September 2021. As of this video recording. So if you want to incorporate some latest information, let's say from Google, Wikipedia, or somewhere else, you can't get that here. The other issue is Atlic is my own software development and data science company. If I want to know how many employees joined last month, ChatGPT can't answer because it doesn't have access to my own internal organization data. So if you use this kind of architecture for building your application, you will hit some roadblocks, or you will rather have some limitation. And look, OpenAI guys are pretty smart actually. If they want, they can address all of this, but their stance is very clear. We will provide foundational APIs, and building framework is something that other people should do. And that's what happens. See, if you have just OpenAI API, it is not enough to build LLM. Therefore, you need some kind of framework where you can call OpenAI GPT-3, GPT-4, or maybe if you want to save the cost, you call some open source models such as Hugging Face, Bloom. There are so many models out there. Let's say you want to use them. You don't want to spend money on OpenAI GPT-3 model. Then this framework should provide that plug and play support, where you can integrate to one of these models and your code kind of remains the same. This framework should also provide integration with Google search, Wikipedia, or even integration with your own organizational databases so that the application can pull information from these various sources as well. And this framework is Langchain. That is what it does. It's a framework that allows you to build applications using LLM. Okay, let's install Langchain now and do some initial setup. Let us first create an account on OpenAI. You can go to OpenAI website, click on login, and create a login using Google or individual email credentials. And once your login is created, you will come to a dashboard. So let me just show you. So you'll go to OpenAI, say login, you're logged in, click on API, and then from your account, you can go to your manage account and API keys. You will find a key here which will look something like sk hyphen something. That is like a password. So you need to use that key in our code for Langchain. You can also create a separate keys for separate projects. So I have some client projects going on, YouTube tutorials. So for each of them, I have a separate key. In your case, you can just use the one key. By the way, you can generate a new key here as well. So let's say you copy that key to some secure place. After that, you won't be able to access it here. So you have to delete and create a new key. Okay, so let's say you have that key ready with you. Here, then you can just import OS module, and then in OS module, you can create an environment variable with that particular key. Your key will be sk something. Okay. In my case, I have stored that key in one Python file. Okay, I don't want to share that key with all of you. That is the reason. And that Python file looks something like this. Secret underscore key.py. It will have my own internal key. I can have n number of keys here, and I'm just importing that variable here and just setting it here. Control enter. So that thing is set. Now let's go to the terminal and install some modules. So you're going to install Langchain module. That's number one. And the second module you're going to install is called pip install OpenAI. Once you have installed those modules, let's now import few important things from Langchain. We are going to import the LLM called OpenAI. Now we are using OpenAI because OpenAI, I know it costs some money, but it is the best one. If you want some other ones, then just hit tab and it will just show you Hugging Face, whatever the other type of whatever other LLMs that it has available. It will show you all of that. We are right now happy with OpenAI, and then I will create my OpenAI model. It has a variable called temperature. Now what temperature means is how creative you want your model to be. So if the temperature is set to, let's say, 0, it means it is very safe, it is not taking any bets. But if it is 1, it will take risk, it might generate wrong output, but it is very creative at the same time. I tend to set it to 0.6, 0.7, things like that. And now in that LLM, you can pass any question. So let's say I want to open a restaurant for Indian food and I want some fancy name for it. I'm not able to come up with that product name idea or restaurant name idea. And let's see what this guy does. And I typed in the same question in here also. See, I want to open a restaurant for Mexican food. It told me this. If you say Indian food, it will tell you something else. So we are using essentially the same concept here. Okay, so here it says, okay, Maharaja's Palace Cuisine. If you say Italian food, see, the name sounds real as if it's an Italian restaurant. So we have imported that OpenAI class which created an LLM, and in the LLM we are just passing a simple text. Now I don't want to keep on changing this same string, so I will now go ahead and create something called a prompt template. So from Langchain.prompts, you can import a prompt template, and in that prompt template you can pass some variables such as input variable. What will be the input variable, by the way? Variables, it will be a cuisine, and then the template that you want looks something like this. So I'll just copy paste here, and what we are doing is just changing that Italian etc with that cuisine variable, and this template is called prompt template. And let's say this is for a restaurant name, that's why I'm saying name here. And once that template is created, you can just say prompt template name dot format, and in that format you can pass cuisine as, let's say, Mexican. And see, I want to open a restaurant for Mexican food. If you say Italian, it will say Italian food. This is more like a Python string formatting. You would be wondering why you don't use Python string formatting. Well, let me just show you that using something called chain. So we are going to use this concept of chain in Langchain, and it is one of the most important objects in Langchain framework. You can figure out from the name of the framework itself. And we are importing LLM chain. And LLM chain is essentially a very simple object where you are saying my LLM is this, whatever you created here, okay, that is my LLM, and my prompt is this prompt template, and this is my chain. And in the chain you can say chain dot run. Let's say I want to open a American restaurant. See, the all American grill and bar. So now here I don't have to pass the whole sentence. I want to open a restaurant for this, that. I just pass the cuisine, the variable, and it will just work every time. Mexican. See, so internally it is calling OpenAI API, and we made that connection via this module here. So if you were using Hugging Face, then you'll have to do the Hugging Face setup, and it will call Hugging Face. Okay, here we are kind of paying that cost. But by the way, when you created that Open API account, you got $5 free credit, so you should be okay. $5 is more than enough for initial learning and exploration, and after that, if you like it, you can go ahead and pay money. So that is the simple chain that we got here. Now let's look at something called a sequential chain. So let me just explain the concept first. So far what we did is we had this chain for generating restaurant name, and it was generating it. But let's say for that restaurant you want to generate a menu item, food menu items. So you can have this second component or a second chain where you pass restaurant name as an input, and it should give you the menu items that you should include in that restaurant. So if it is Indian restaurant, it will say paneer tikka, mango lassi, etc. If it is Mexican, it will say quesadilla, burrito, things like that. This thing is called simple sequential chain. And let's code that up. But just to clarify the idea here, you have one input and one output, and you can have intermediate steps where the input of the second step is the output of the first step. It is as easy as that. So here, once again, I'm generating everything from scratch. I have generated the name chain the same way that we did before. This is the exact copy paste of the previous code, so nothing fancy here. And then we are going to create another chain, and I'm just copy pasting just to save your time, where the input is restaurant name, and we are saying suggest me some food menu items for restaurant that. So it is like saying this. See, you are saying I want to open a restaurant for Indian food, suggest a fancy name for this, only one name please. So let's say you talk to ChatGPT, and ChatGPT generated this. Now you are saying that generate food menu items for saffron spice, and then return it as a comma separated list. See, this is what you want. You want to generate all this list, and you have now two chains, which we are going to do control enter and execute this code. And now from Langchain dot chains, it will show you all kind of chains. You're going to import a simple sequential chain. Okay, and that simple sequential chain will contain these individual chains that we created. And by the way, the order matters here. So this is a restaurant name chain, and then you have a food item chain, and that's it. And now you will say chain dot run. Let's say you want to generate it for Indian food. You're getting a response here, and you print a response Sometimes it takes time, so you have to wait for a few seconds, but it will generate the menu items. Ta-dan. See, lamb korma, vegetable chal fry, saag paneer, yummy, huh? You're probably getting water in your mouth. Let's do Mexican for all those Mexican food lovers. So while this chain looks good, it is generating those food menu items. I'm not getting the restaurant name as such, because say for Mexican food it is saying all these items, but what is the restaurant name? That was that intermediate step here. That was the intermediate step, but in the output, in the simple sequential chain, it gives you just one output. But I want the restaurant name and the menu items both. For that, we have to use a different chain called sequential chain. And this sequential chain can have multiple input, multiple outputs. So I can just say, okay, give me a name for Indian restaurant, which is vegan. And then in the output, I can say, give me a restaurant name and items both as an output. All right. So let's try something like this here. I think this whole code kind of remains the same. I'm just going to add one or two extra things here. So see, this is my first chain, and the extra thing that I have added is the output key. So the output of the first chain is the restaurant name, and the second chain looks something like this, where the output key is menu items. Okay, and now let's create the simple sequencing chain. So I'm going to say from Langchain.chains import sequential chain. We already used simple sequential chain. This is a sequential chain which is little kind of generic. So sequential chain will take, what kind of parameters will it take? Well, first of all, it will say chains, and these are the two chains I have. And then my input variables, you can specify all the input variables. So input variables, I'm not including that vegan, etc. Let's keep things simple. All I want is two output, remaining things are same. Okay, so in the output variables, I should say that I want a restaurant name and the menu items as my output variable. And let's call this a chain. And by the way, when you run this chain, you can't just say Mexican, because you might have multiple input variables. That's why you need to give a dictionary. You will say cuisine is, let's say, Arabic. Run not supported. Okay, run is not. Yeah, so run is not supported. You have to just call it just like that. No function, just chain and then bracket, just give the argument. And see, hummus with pita bread, falafel, and the name of the restaurant is the Arabian Bistro. So it's giving, in fact, it's giving input as well. So it's giving input and both the outputs. Whatever code we have written so far, we will use that code and create a Streamlit based application for restaurant name generator. I'm in my C code directory. I have created this empty folder called restaurant name generator. You see there are no files here. And I'm going to now launch PyCharm, which is a free Python code editor. And in this, you can select open and you can open that particular folder. So I will go to my C code directory, and in that I will locate a restaurant name generator, hit OK. And it will create a, I think, empty main.py file, and I can just remove the content here. And I'm going to just import a Streamlit library first. Now, if you don't know about Streamlit, it is a library that allows data scientists to build POC application, proof of concept applications, simple applications very, very quickly. You don't have to use front-end frameworks such as React, JS, etc. This library will allow you to do all of these things very, very fast. So let me just show you. So you can just create a simple application with a title, restaurant name generator. And by the way, you have to do pip install Streamlit before you start using it. Otherwise, you'll get an error. So make sure you have run that. And this is the simple app with one title. Now I can go to terminal and I can just say Streamlit run main.py. and it is going to open up an application in my browser. See, simple application with this particular title. Now I can create the picker where you can pick the cuisine, and for that I'll use a sidebar. So in Streamlit there is something called sidebar where you can create a select box and give a name to that box. So you will say pick a cuisine and give all the options that you want in that particular drop down. So I will just put bunch of cuisines, Indian, American, Mexican, and so on. And then here you will say if, or let me just show you how this looks. So just say hit Control S, save, and click on rerun. You can go here and rerun, or just press R key and it will show you. See, you get this kind of nice picker. And if someone picks any entry, let's say someone picks Mexican, what's going to happen is that call is going to return that value in a variable which we will store in this cuisine. Okay, so I will just store it in this particular variable, and you can say if cuisine, then do something. Okay, what do I want to do? I want to generate the restaurant, fancy restaurant name and list of menu items here. For that, let me just write a dummy code here. So I will just call that function, let's say get restaurant name and items, where you supply the cuisine as input, and it returns, let's say, restaurant name. It is always a good idea to write this kind of stub function or empty function so that you can check your wiring and then you can write the actual code in that function. So let's say my restaurant name is Curry Delight and my menu items is whatever items you like. Okay, so if cuisine, then get those things as a response, and then from the response, let's say the restaurant name, I can show it here on the right hand side. See, here somewhere below this header I want to show it, and I will use maybe let's say st.header. I will use st.header as a UI control. So let's do this st.header, and when I get the menu items, so let me get the menu items here. So the menu items are going to be this menu items here, and whenever you have comma separated string, you can call this split function and specify the separator, which is comma here, and this should return you a list. And once you get that list, you can iterate over that list and you can write those items here. I can just say item, and maybe I can put some character just to indicate this is an item. You can also write like kind of like a header where you'll say, okay, these are menu items. Okay, hit save. This code is ready. You go back to your UI, rerun, and see, you're getting the restaurant name and the menu items. Now, when you change this selection, it's not going to change because obviously we are returning the hard-coded response. And the next step is to write that code which we wrote in our Jupyter notebook and put that code here. Okay. And since I like to modularize my code, I'm going to create a new Python file. Let's call it Langchain helper. And in this file, I will copy paste this function. And here you can import that module and you just simply call that here. See? Now let's focus on Langchain helper. So what do we need to do here? Well, the same thing that we did in our notebook. So I'm just going to copy paste some code from my notebook here. Okay, we don't need to go over it because we have already written that code. I will also create file for my secret key. So I will call it secret key. And in that secret key file, I will place my OpenAI secret key. Now I'm not going to show you my key because of course it's a private thing, but you will type whatever key you got. Remember, you got $5 credit, so you can do a lot of things with $5 is more than enough. So put that thing here, and then you are using that key. See, you are importing that variable from that Python file here directly. Okay, so my key is ready. What else do I need to do? Well, again, copy paste, business folks. Copy paste is a boon for any programmer or a data scientist. So we just copy pasted the code for the sequential chain that we wrote in our notebook. See, here we create a restaurant name chain. Here we create menu items chain, and we just return this response, folks. This is so straightforward. Okay, and I have this habit of creating this function, main function, just so that I can test it. So I will say if name is underscore main, then print generate restaurant name, let's say Italian. Okay, and now what I'll do is I'll pause the video and put my real secret key here. All right, my secret key, I have placed it, and now I can run it and see what happens. So we are generating Italian food restaurant name and the menu items. Perfect. So the restaurant name is La Dolce Vita, whatever, and menu items are Margherita pizza, Alfredo, lasagna, and all that. One thing I'm noticing here is I see some extra slash and characters here. So maybe we need to remove them. So the way to do that would be, let's go back to our Streamlit code. And instead of just saying responsible restaurant name, we can call this strip function that will remove the leading and trailing white spaces, including those slash and characters. And you can use that same thing here as well before calling split. So hit Control S, save. Let's go back, rerun. Ta-dan. See, Italian food. This is my restaurant name. Menu item, you can change it to Mexican, change it to whatever, just play with it. And folks, the art of getting skillful at coding is to practice. Just by watching this video, you're not going to learn it. So make sure you're practicing while watching this video. All right, our Streamlit application is ready. As a next step, we are going to look into something called agents, which is a very powerful concept in Langchain. And by the way, all the code that we are writing, check video description. We are going to give you all of that code. Agents is a very powerful concept in Langchain. What happens when you type this in ChatGPT? When you say, give me 2 flights, options from New York to Delhi on a given date, obviously it won't be able to answer because it has knowledge till September 2021. But if you have ChatGPT Plus subscription, there is this thing called plugins, and I have installed those plugins, especially the Expedia plugin. Expedia is a website which helps you find tickets. And when I give the same question now with the plugin enabled, magically it will start working. So it will go to Expedia plugin, try to pull the information on the flights for a given date and given source and destination, and then it will start typing those 2 options. See, number 1 option is only, I think, $500 ticket, $518 ticket, which is a pretty good deal, by the way. I think I should book it for my next India trip. And there is the second option, and it will give you a link where you can go and book those tickets on Expedia. So what exactly happened when we enable this plugin? Let's try to understand that. So when you think about LLM, many people think that it is just a knowledge engine. It has knowledge and it just tries to give answer based on that knowledge. But the knowledge is only limited till September 2021. The thing that we miss out is it has a reasoning component. So it is a reasoning engine too. And using that reasoning engine, it can figure out that when someone types this kind of question, see, when as a human, when we look at these questions, what do we think? Let's say if we have to go to Wikipedia, or not Wikipedia, Expedia, and if we have to type, convert this question, let's say if your friend asks you this question, and let's say you are that reasoning engine, you go to Expedia And in the source, you will put New York. Destination, you will put Delhi. Date, you will put 1st August. How can you do that? Because you have that reasoning engine in your brain. Similarly, LLM has a reasoning engine using which from that sentence, it will figure out source is this, destination is this, that, and it will call the Expedia plugin, and that will return the response back. Let's look at some other question. When was Elon Musk born? What is his age now in 2023? Now, maybe this can be answered by the LLM's knowledge, but let's say you are asking some question which is related to an event which happened in 2022. Now, this guy doesn't have knowledge after September 2021, but once again, it has a reasoning capability. So it will say, okay, in order to answer that question, first I need to find out when was Elon Musk born. For that, it can use things like Wikipedia. So agents essentially do this thing. Agents will have tools, and using that tool, it will try to fetch the answer. So Elon Musk was born in 1971. And then there could be another tool which will tell you 2023 minus 1971. How much is that? So there is a math tool that it can use to compute that. And it will in the end say Elon Musk is 52-year-old. So this is what agents are. Agents will connect with external tools. It will use LLM's reasoning capabilities to perform a given task. Let's look at a different question. How much was US GDP in 2022? Plus 5, I'm doing just like it's a silly operation, no one cares. But US GDP in 2022, LLM doesn't know because its knowledge is still 2021. So it will go to Google, it will find that answer, and then it will use math tool to do plus 5. All these tools like Google search tool, math tool, and Wikipedia tools are available as part of Langchain, and you can configure your agent. So your agent is nothing but using all these tools and LLM's reasoning capability to perform a given task. That is your agent. And this agent can be used in our Jupyter notebook. So that's what I'm going to show you next. So let's first import couple of important modules and classes. And once I have imported them, I will create tools. So I will say load tools. And I will give list of tools. Now, if you do Google search on tools here, so let's say if you do Google search, Langchain agent load tools, you will come here, you will see list of tools. See, I have Wikipedia as a tool, I have Twilio, I have all these tools that I can use. So we are going to use Wikipedia tool here. It is called Wikipedia, and the math tool is called LLM math. And here you need to provide the LLM variable is the one which we created above somewhere here. See, this is the variable. Okay, so this thing is called tools, and then you can create an agent using this initialize agent method. Okay, so initialize agent method will take tools, it will take LLM, and it will take agent. And in the agent, I will give this 0. Now see, hold on, 0 short React description. React means thought and action. So when we are reasoning, we first have a thought, then we figure out where to go, and we take an action. So it mimics that particular concept here. I will call this an agent, and then I will ask the question agent.run when was Elon Musk born and what is his age in 2023. So let's see what this gives us. See, perfect. It says 52-year-old in 2023. If you want to go step by step in the reasoning process, you can say verbose is equal to true, and it will tell you. By the way, verbose is equal to true is the variable that you can use here in any function to kind of figure out the internal steps that it is taking. So here, the first step, when it encounters this question, it knows actually that it has to go to Wikipedia to get the birth date of Elon Musk. So it went to Elon Musk Wikipedia page, and which will have this particular date here. And then I think it uses the math tool. Sometimes, I don't know, it should have used the math tool. Elon was it doesn't show, but if you rerun it again. Okay, I don't know why this is not working, but previously I was seeing that. Let me show you a previous snapshot that I have. Here it says, okay, it went to Wikipedia for Elon Musk's birth date, and then it used the action as a calculator. So there it is using the LLM math tool, and it is just calculating the final answer. It is saying it is 52-year old. Let's try a different option. So this time we are going to use SERP API. So if you don't know about SERP API, it is Google Search API. Whatever you do in Google and what results it gives you, if you want to access those results programmatically, you can use this particular API. You can log in using your Gmail account. I have already logged in. And when you go to dashboard, it will give you this API key. So this is similar to our OpenAI API key. It will be a big string. I have stored that API key into my private file, that secret key file that I have, and I'm going to initialize some environment variable. So for SERP API, you need to initialize this variable, and this is the key which I got from there. Okay, so you can just copy paste this key if you want to keep things simple. I don't want to show that key publicly here. That's why I have this thing here. And once I have this thing, the next steps are kind of similar. So I can just copy paste pretty much everything here, and I will just say, okay, initialize the agent. SERP API and LLM math are the two tools I'm going to use. And in my agent, I will say agent.run. And what was the US GDP in 2022 and +5. Okay. And while it is executing it, let's do Google here. So when you do Google US GDP 2022, it will tell you 25.46. So this SERP API, this API will do Google search, and it will tell you the answer that it is this. So check this. So first it is searching US GDP this, and then it is adding phi number to this, and it is giving you this particular result. We'll talk more about agents in our future videos. One thing I've noticed is agents are not perfect. Sometimes they give stupid answer. This whole thing is evolving, so in the future it will get better. But for agent, this is what we have, and now we will talk about memory. When you look at any chatbot application such as ChatGPT, you will notice that it remembers the past conversation exchange. Here I asked who won the first cricket World Cup, then a totally irrelevant conversation, what is 5 plus 5. Then I'm asking who was the captain of the winning team. Now see, here I did not say which match, which game, cricket, football, etc. But it remembers that I'm talking about cricket, and it is giving me a relevant answer. Same thing happens with human conversation. We start a topic, then we keep on saying things, but we remember what the topic is about. If you look at the LLM chain, by default, these chains do not have memory. They are stateless. And if you look at the available methods that this chain has, you'll find that it has an element called memory. Here, see memory. And if you check the memory, so here, if you try to print the memory, see, you don't get anything because the object is set to none. Now, if you want, you can attach memory to it. So for memory, you have to create an additional object and attach it so that it remembers all these conversations. This is useful, especially if you're building a chatbot, let's say for your customer care department. In that, many times they need to save the transcripts of those conversations for legal and compliance reasons. So here, I'm going to import an object called conversational buffer memory, which is a very common type of memory in Langchain module, and create an object of that class. So I will just say this is a conversational buffer memory, and then the same chain I will print here, but I will just pass memory as an additional argument. Okay. And then I'll run the same chain one more time for a different question. Now, when you look at chain.memory, see, there is a memory attached to it. We explicitly attach this conversation memory to it. And if you look at the buffer and if you just print it for nice alignment, etc., see, human, then AI this, human, and AI this. Now, this looks good. You can save this into your database as a saved transcript of your customer service center conversation. But one problem with this particular object, which is conversation buffer memory, is that it will keep on growing endlessly. So let's say you have 100 conversational exchanges, and by that what I mean is one question answer pair. So one question answer pair is one conversational exchange. This is second. So in total, this is 2 conversational exchange. So here, if you have 100 conversational exchange, what's going to happen is next time when you ask a question to OpenAI, when you say chain.run, it is going to send all this past history to OpenAI, and OpenAI charges you per token. So this is 1 token, second token, third, fourth, and so on. For 1,000 token, they charge like $0.002 something based on the model. So your cost is going to go up. So if you want to save the cost and kind of do things in an optimized way, you need to restrict this buffer size. You can say, just remember last 5 conversational exchanges, okay? And this thing can be done using something called conversation chain. So OpenAI Langchain provides this conversation chain, which is just very simple object. So let me just create that conversation chain where you can just pass LLM is equal to OpenAI, temperature is equal to 0.7, and I'll just call it convo. And let's check the default prompt that is associated with it. See, default prompt is this. Let me just check the template. Let me just print the template associated with this. This is the default template that comes. And it says that the following is a friendly conversation between human and AI, and there is history and there is input. So if you look at this conversation window here, there is a history. This is the history. And the next question you're going to type is the input. So input, history, same way, input, history, okay? Now, when you ask a bunch of questions to this, so I'm just going to copy paste those questions here. What is 5 plus 5? And then who was the captain of the winning team? Now, when you do convo.memory, it won't be empty, because by default conversation chain has this memory associated with it. So by default, this conversation chain object comes with inbuilt conversation buffer memory. And if you print the buffer, you will see the entire transcript of our conversation. Now, while this looks good, once again, think about the OpenAI token cost. If this keeps on building the buffer endlessly, then you might have 5,000 tokens in one conversation. And when you make a next call like this, it's going to actually send entire history, entire conversation to OpenAI. And that will increase your bill on the API call. To tackle that problem, maybe what you can do is you can say, just send only last 10 or 20 conversational exchanges, because that's what I care about. That might be enough based on the use case that you're dealing with. And for that, there is an object called from langchain.memory import. There is a conversational buffer window memory. You are restricting the window. You are saying, let's say my window, and k is the parameter. You're saying just remember only last 1 conversational exchange, which is 1 question answer pair. Okay, so let's try this out and let's see how this goes. So I'm going to copy paste some code here, created a same conversational chain object, asking my first question, asking my second question. Now, when I ask this second question here, what is 5 plus 5? It remembers the previous exchange. But when I ask the third question here, it remembers only what is 5 plus 5. It doesn't remember this. It's like a short-term memory loss, like Memento or Ghazni movie. It just forgot what happened here. So when I ask this question, it will say, I'm sorry, I don't know, because it doesn't know which game you're talking about, which particular match you're talking about. Okay, so here I know it's probably not the best example, but the idea is I wanted to demonstrate this k parameter here, and based on this use case, you might see benefit in using conversational buffer window memory.
That is all we had in terms of Langchain fundamentals. Now, using these fundamentals which you just learned now, we are going to build two end-to-end projects. First project is in finance domain. Second project is in retail domain. I previously published these two projects on YouTube, and I'm going to use the same two videos because these are very high quality end-to-end projects. Below in the video description, the link for the code is also available. So let's start with the first project now. Today we will build an end-to-end LLM project that covers a real-life industry use case of equity research analysis. We will build a news research tool where you can give a bunch of news article URLs, and then when you ask a question, it will retrieve the answer based on those news articles. In terms of technology, we have used Langchain, OpenAI and Streamlit. To make this project more interesting, we have added some fun storytelling as well. So let's take a look at that story first.
What if Rocky Bhai lived in the ChatGPT era? How would he invest all his money? Would he use ChatGPT to find best investments? No way. He would hire someone for that. Rocky Bhai's recruitment team got Peter Pandey, the equity research analyst. Peter read lengthy stock market articles for his research, but Rocky Bhai did not like it. Rocky Bhai said,
इस पेड़ से तो कभी काम नहीं होगा.
Peter promised to create a chatbot like ChatGPT for his investment. Rocky Bhai liked Peter's grit and he said,
Fasten your seatbelt.
So get ready folks, we are going to create a chatbot for Rocky Bhai. Perhaps the Rocky Boat. Equity research analysts such as Peter Pandey in our Rocky Bhai story do exist in real life. Let me give an example of a mutual fund. You might know about all these mutual funds where you can invest your money. So all these three yellow color people are the common people like us who are investing their money in the mutual fund. And mutual fund will eventually invest in individual stocks. Now they need to pick right amount of stocks for which they might have a team of research analysts. And the job of this team is to provide a research on these companies. Let's say Tata Motors, Reliance, how these companies are doing, or what are going to be their profits next year, how is their management, is this a good stock to buy? You know, they do all this research. And in this research team, every individual person might have a couple of stock. Let's say Peter Pandey is working for HDFC Mutual Fund. He might be looking at Tata Motors and Reliance, and his job is to do research on these stocks. Okay, so daily he comes to his job and he will read a bunch of articles from Money Control, Economic Times, or maybe he has access to premium products such as Bloomberg Terminal, and he will do all his research based on the news articles, the earning report, the quarterly financial reports, and so on. Now you can understand reading news articles from these various websites is tedious task. There are so many articles, so much information to consume. See here I'm showing a P&L of Tata Motors. Why don't we build a tool which looks like this, where you can put bunch of news article on left hand side. I'm showing just 3, you can have n number of articles. And then when you ask a question, okay, so see I'm showing all these articles, and these are like different articles on moneycontrol.com, and when you post this question, it will retrieve the answer 6.55 to 8.1 lakh. That was the answer. And it pulled that from this particular article, see? And the article link is in the below, okay? And you can also say, okay, give me a summary. I mean, it doesn't have to be the number. The answer doesn't have to be only one number. It can also summarize the entire article, okay? I know about all this because when I was working with Bloomberg for 12 years, in Bloomberg Terminal, we used to get research reports from Jefferies, Oppenheimer, all these different companies, and we would process that data and show that data on the terminal. All right, so I hope you have some understanding of the industry use case. This is a real industry use case. This tool can be used by companies such as Jeffries Oppenheimer, all right, folks? So this is not some toy project. Let's think about technical architecture now. We need to go back to basics in order to build the technical architecture. Whenever you talk about building any LLM app, the first thing that comes to your mind is, can I use ChatGPT for this? Because ChatGPT is free. Well, actually you can. You type your question in ChatGPT and you say, answer this question based on below article. Do not make things up. And then from that news website, you copy paste the article here. And what happens is, ChatGPT has a capability. See, EPS is 8.35. It can pull the answer from that given text. So the question is then, why do I need to build this tool? Why can't I use ChatGPT for this purpose? Apparently, there are 3 issues with this approach. Number 1 is copy pasting articles is tedious. Equity research analysts are busy folks. They don't have time to go to website, copy paste, and then get the answer. They also need an aggregate knowledge base, because when they're asking questions, they don't know where the answer might be. They might have this question, how many let's say Tata Nano, Tata Motors sold in last quarter. Now the answer might be in any article. So how do they know which article to pull? And also some answers might be spread over 3 or 4 different articles. Okay. So they need some kind of aggregate knowledge base, and ChatGPT can't give that. And third issue is ChatGPT's word limit. In ChatGPT, you can't copy paste a huge article. It has a limit on number of words you can supply. So we need to build some kind of tool where it can go to the news website, which our equity research analyst is putting trust on, and it pulls all those articles into some kind of knowledge base. So here the database that I'm showing here is some kind of knowledge base, and you can build a ChatGPT like chatbot which can pull data from that knowledge base. Now let's think about this particular article on NVIDIA. Let's say I have this particular question, okay? What was NVIDIA's operating margin compared to other companies in semiconductor industry? And give me the answer based on following article. And when I give that entire article, it will give me the answer in a perfectly fine expected manner. But let's think about it. We are building a tool here. We are not using ChatGPT. So obviously behind the scene, we will be calling OpenAI API. And whenever you call a OpenAI API, there is a cost associated with it per 1,000 tokens, or if you want to think about tokens in a simple layman language, you can say, okay, word maybe. Okay. So amount of text that you supply to OpenAI, there will be cost associated with it. So if you supply more text, there is more cost. But read the question carefully, folks. This is very interesting. The answer of this question is actually in the first paragraph. We don't have to supply second paragraph. It is not necessary. Because see, 17.37%, that's the answer. And therefore, you don't need to supply the second paragraph. So is there a way we can smartly figure out that, okay, for this question, I need to only give this much chunk. If you do that, you will save a lot of money on your OpenAI bill. Okay. So just think about this article as 2 different paragraphs. And based on the question, you can figure out which paragraph to supply in your prompt. Thinking about this in a generic way, you might have a bunch of articles, let's say on NVIDIA, and when you are asking a question, what's the price of H100 GPU, you want to figure out a relevant chunk. So let's say the relevant chunks where H100 GPU price is mentioned are chunk 4 and chunk 2. In this case, when you are building your prompt, you don't need to give all the chunks 1 to n into your prompt. You can just give chunk 2 and chunk 4. Chunk is just a block of text which is relevant where the answer might be present for your given question. Okay. And when you do that, it will give you the fine answer. So the question now comes is, how do I find relevant chunks? You can't use direct keyword search. I can't say, okay, H100 GPU. It's like Control F. Try to look into all the chunks, and wherever H100 GPU is present, give me those chunks. Okay, H100 GPU is probably a simple example, but look at this example. When I go to Google and say calories in apple versus revenue of apple, it knows that the first one is a fruit and the second one is a company. How does it know that? Well, it uses a concept of semantic search. It looks at the context. We as a human, when I say calorie, I kind of figure out it's a fruit, and revenue is of apple is company. Similarly, in any NLP application, if you're using semantic search, it can figure out based on the context what is the meaning of this word apple. Is it a fruit or is it a company? And we use something called word embedding and or sentence embedding and a vector database for this. I have given a separate video for this, so because this explanation might take more time, so I don't want to spend time explaining all these concepts. If you know this already, then fine, you can move ahead. Otherwise, the link of this video is in description below, so you can pause the video and watch that one first. But let's say, just for simplicity, embeddings and vector databases allow you to figure out, so embeddings will allow you to figure out a relevant chunk, and vector databases will allow you to kind of perform a faster search on that database, and then you can give your prompt to OpenAI and get the answer. So now thinking about the technical architecture, the first component will be some kind of document loader where you can get all your news articles and load it into that object. And then the second one will be splitting that into multiple chunks and then storing that into a vector database, so that when you have a given question, let's say I have a given question, what is the price of H100 GPU? You can go to vector database and retrieve relevant chunk, which is chunk 2 and chunk 4. Okay, so vector database allows you to perform that faster search, because this vector database might have millions and millions of records. Okay, so the way vector databases are designed, they help you do a faster search. And once you have that question, you give it to your prompt and you get your answer. In terms of Langchain, we will be using all these classes that I have shown in the orange color. And we will be building our application. Now, for a short-term phase 1, we are building this particular tool in Streamlit. When you are doing this project in the industry, let's say you are working as a data scientist for Jeffries, you're not going to build the whole project in one go. You will first build POC, proof of concept, where you will build this kind of tool in Streamlit. Left side, number of article URLs, and the right side, you put a question, gives answer. So that way you get a confidence that this approach works. And once we are happy with the result of this tool, for long term, the architecture may look something like this. You need to first build a database ingestion system. It will have two different systems. First one is a database ingestion system, where you go to your trustworthy news article website, you write a web scraper and you have it implemented either in native Python or tool like Bright Data, and then you run that on some kind of cron job schedule. Let's say this cron job runs every 2 hours or every 1 hour. It will pull the data and it will convert that text into embedding vectors using OpenAI or Llama or BERT, whatever embedding you want to use. Then that goes into vector database, and for vector database we can use Pinecode, Milvus, Chroma. These are like popular ones today. We can use any of these solutions, and that will be your database ingestion system. The second component will be chatbot, where in React or some kind of UI framework you will build chatbot similar to ChatGPT. A person types in a question gets converted into embedding. Once again, OpenAI or Llama, whatever embedding you want to use. And then from vector database, you pull relevant chunks. So this green and orange are relevant chunks, which matches with the question, what was Q3 2023 EPS for Tata Motors? And then based on those chunks, you form your prompt, you give it to your LLM, and the answer, you put it back into your UI for the chatbot. So again, this is the overall architecture that you will be working with. Remember that when you're working in industry as a NLP engineer or a data scientist, you first do brainstorming with your team, you come up with this kind of nice technical architecture, and then you start doing some coding. Okay, you don't want to go into a wrong direction. All right, so in the next section, we'll be talking about text loaders. Before we talk about text loaders, make sure you have watched this Langchain crash course so you have a basic overview of Langchain library. Assuming that you have watched this course, the next step for you will be to install Langchain by running pip install Langchain. This is the command that you run. So let me just show you. So you will run pip install Langchain to install Langchain library. And once that is installed, you can launch a Jupyter notebook, and there you can import the class. So you can say from langchain.document loaders import text loader. Okay. So I have imported a simple text loader. There are multiple types of loaders that Langchain offers, and we will look into them one by one. So text loader allows you to load data from a text file. Here I have a NVIDIA's news in one text file, which is called NVDA_news_1.txt. So I will just load that here and kind of show you how this thing works. So NVDA news, I think 1.txt, and I will call it loader, and then you will do loader.load, and then it returns a data object. And if you print a data object, it looks something like this. It has all the news content inside it, and if you look at it, it is actually an array. Okay, an array's 0th element is that document, which has page content as one of its elements. So let me just show you here in a separate cell. So here, if you do page content, see, it shows you the entire text content that it has. The other element that this class has is metadata. So metadata is the name of your text file. Now, if you Google, let's say, Langchain text loader, so let me do Langchain documentation. And if you go to the documentation here, you will find, let's see, you will find the documentation for various loader classes that you have. Now it is sometimes hard to navigate this, and it can change based on at what time you're looking at this. But see, document loaders Python guide will give you all these loaders. So this is a text loader. The second one they have is a CSV loader. So let me talk about CSV loader real quick. So I'll just copy paste this thing here, and I have a CSV loader class here, CSV loader. Obviously I need to pass a CSV file, and luckily I have this movies.csv file which has around 9 records. You can see 9 records where you have movie title, industry, the revenue, and so on. I will provide all these files in video description below, so make sure you check it. Code, all the files, everything will be provided to you. Here I will say movies.csv, that will give you a loader, and loader.load, that will give you data. Okay, loader.load. And if you look at length of data, you will find 9 records, because in the CSV file we had 9 records. And if you look at the very first record, once again you're getting that document class. Okay, you can say type here and you will see the document class from Langchain library, and that class has 2 elements, right? Page content, which is a page content. So let's see what is inside page content. So page content is entire record. Okay, entire record in your CSV file, which has movie ID, title, and so on, separated by /n. And if you look at metadata, it has the movies.csv. Now one may argue that this metadata, I want to have maybe movie's name or movie ID as kind of the metadata. And metadata is something that we will be using in our project. So remember in the preview we saw, when you type in any questions and it will not provide you the answer, but it will provide you a source link. So how does it reference back to the source link? The answer is, it is through this metadata, and we'll look into it. But for now, here I will say that my source column here, so my source column is, let's say, movie ID or title. Okay, so what are the columns I have? So movie ID, it has title, Maybe I can keep it title as a source column. So here, when I keep it as title, what you will see is in the metadata, you get KGF2. For the first record, KGF2, right? See, for the first record, KGF2, second one, Doctor Strange, and so on. So you can view all the records. So here is one record, and then here is the metadata. See, metadata, and so on. Okay, now let's talk about the unstructured URL loader, because that is something we'll be using in our project. In our project, we will be going through some news article, let's say this particular article on HDFC Bank, and we want to load the text content from this article directly into Jupyter Notebook using some ready-made Langchain class, and that class is unstructured URL loader. So this is how you import it. And by the way, you need to install a couple of libraries before that, and the way you install those libraries is by providing this particular command. Okay, in the notebook, if you run this, it will install all these libraries. Other thing is you can copy paste this into your git bash or Windows command shell and install it. Okay, it's just a usual thing, folks. You should know how to install libraries. So these are the all libraries that you need to use. And by the way, unstructured URL loader uses a library called unstructured. So if you do Python unstructured library, this is the library that it uses underneath to kind of go to that website, look into the DOM object, the HTML structure, and pull all the information. So let's create that class, and the arguments is all the URLs that you want to supply, and the two URLs that I want to supply are basically, I'll just supply two different articles here. Okay, and that will be your loader. So my loader is this, and our usual step is loader.load. You get data as a return value, and when you do length of data, it will take some time, but it will return 2 because you have 2 articles, and you look at the first article and see, again, same thing, page content. And let's see, what do we have in metadata? See, in metadata, you have the source URL link. So metadata is the source URL link, and we will be using this in our news research tool. After we load our documents through loader classes in Langchain, next step is to do text splitting. And we have character text splitter, recursive text splitter, these kind of classes. The reason we do this is because any and LLM will have a token size limit. That's why we need to reduce the big block of text into smaller chunks so that it is within this particular limit. And what may happen because of these classes that we're using in from Langchain is individual chunks that we get after we do split might not be very big, or it might not be closer to the token limit, which is 4097. Let's say the first chunk is 3000, second chunk is 1000. It would make sense if I merge these two so that it is closer to the limit and it kind of works more efficiently. So we have to perform merge step. So first you have a huge block of text, you divide things into smaller chunks, and then you can perform merge so that each individual chunks that you're getting, which is in this blue, green, orange color, they're closer to that limit, which could be 4097, 2000, depends on the LLM that you're using. We also want to do some overlapping so that when you are reading this orange paragraph, you need some context from the blue paragraph, which is one step ahead. So you see, part of this blue paragraph goes into orange also. So that is chunk overlapping. Similarly, part of this orange paragraph goes into this green chunk also. So you see this orange thing at the top, that is called overlapping the chunks. All of this can be done using some simple APIs in Langchain. So let's look at it. Here I have taken the Wikipedia article of Interstellar movie. You might have seen that science fiction movie, and we are going to perform text splitting on this one. Now when you think about text splitting, let's say I have a limit of 200 tokens that I'm using in my LLM. How do you split this text so that each chunk is of size 200. Well, the obvious thing that comes to your mind is, why don't we use simple slice operator in Python and kind of divide things that way? But when I do that, you will notice that it might cut off the words in between. See, MAT. What is MAT? Mad demon, right? So here it is kind of cutting that off and doesn't look that great. You at least want to have a complete word. So this simple slice operator is not gonna work. Then you'll say, oh, what's a big deal? I might write a for loop, this kind of for loop, where each of the chunks, so if you look at these chunks, each of these chunks is less than 200. Okay, you can do that. But again, this writing this kind of for loops is little tedious and it can have other issues as well. Langchain provides a very simple API so that you don't have to do all this work manually. And that API is given through various text splitter classes. So let's try the first simple one. So from langchain.textsplitter, you can import, let's say, character text splitter. Okay. And when you have this character text splitter class, it will take separator as an argument, separator as in through which character you want to separate things out. Here, let's say we want to separate things out with new line character, which is /n, which means each line can be one chunk or multiple of those lines, because it will do merge steps also. And my chunk size is, let's say, 200. As such, it is like 4000 something, but just for simplicity, we are saying 200. And chunk overlap, I will keep it 0 just to keep things simple. And this is my splitter. Okay, and that splitter I can use to split the text. So I will say split text, and here is my text, and what I'm getting as a return is the chunks. And let's check the chunks length. Okay, chunks length is 9, and if you look at it, see, it's like 1, this is first chunk, second, third, and so on. And if you look at the individual chunks length, let's say for chunk in chunk, we will print the length of the chunk. You will notice that while most of the chunks are less than 200, there are some which is more than 200. See, the chunk size for these chunks is more than 200. So why did that happen? Well, let's look at some of those chunks. So the last two are kind of big. So if you look at the last two ones, you will notice that, see, this one is pretty big. In that entire chunk, there is no /n. It's like a one big or multiple sentences without /n. So obviously, it can exceed the size. Maybe you can change this /n to dot, so that, you know, after every sentence ends, it will just take that as one fragment. But what if you have a bunch of questions? So you might not have dot. Well, you can use space, but no matter what you use, you will always face one or the other issue. For some cases, character text splitter will work, but we need something little more advanced, which can split things on multiple separators. And maybe we can have some rules that first divide things by 2/n, then 1/n, then dot, then space, things like that. And this is something that you could do using character text splitter, which is of recursive nature, and it is called a recursive character text splitter. Okay, so in recursive character text splitter, the arguments are kind of going to be the same, except that you can provide a list of separators. See, here you provide just one separator. Here you can provide list of separator. So I can say, okay, my first separator is /n, second one is /n, third one could be dot, or let's say space, and chunk size and chunk overlap, I'll just keep it same, and I will call this R splitter. Okay, and we will split our text. So let's say you are splitting your text, you store it in chunks, and you look at the length of the chunks. Okay, so total 13, and I will also print the size of the individual chunks here. And you can see that majority of them are now, or actually all of them are less than 200. So let's understand how it works under the hood. So what this will do internally, see, you'll just make one API call, but internally what it is doing is this. So first it will try the first separator, which is this, correct? And it will split the things. So now we had a big text block. It split that into 3 chunks. See, 1, 2, 3. Okay, that is what it did. And once again, if you want to print the size, I can print it here. See, all 3 of them are more than 200 size because we are splitting using /n. So then let's think about the first chunk itself. So first chunk is this. I will just call it first split just to kind of keep things simple. So this is my first split. And if you look at the length of the first split, it is 439. When Langchain detects that, see, first it will separate things out using /n. Then it will check individual chunks. So individual chunks are 3. Okay, this is 439. So when it says that this is more than the specified size, which is 200, it will further split that using the second operator, which is /n. So here what it will do internally is it will say split this using /n, and it will get again 3 more splits. Okay, and if you look at the size of these 3 splits, let's look at the first split. So first split, if you look at it, or let me just say second split is equal to this, and in the second split, if you look at the length of the first one, it is less than 200, so it is fine. Second one is 121, it is fine. But if you look at the third one, it is 210, so it is definitely more than 200. So what it will do is it will then go look at the third separator, which is space, and then it will separate things out. And once it separates things out, then it will again merge. We looked at the merge step, if you remember from here. See, it will also do merging because each individual chunk size might be too small, so it will just kind of merge everything. So obviously when you split things apart using space, so let's do that. So when I split things apart using space, obviously each chunk will be very less, right? This chunk is only 3 character, this is 2 character, 1 character. We can't have chunk which is that small. So it will then merge those things as I have shown you in the slide. It will merge things such that it is kind of optimized. So what it will do is this. See, let me just print for chunk in second split, print the length of the chunk. First two, it will keep it as it is. The third one, it will divide. So what is our size? 200. So it will say, it will create one chunk using size 200, the other one using 10, roughly. It could be plus or minus b because you need to keep your word intact. You can't break the word apart. So that is the reason when we are using this API, see, you got 199 and 10. See, 210. I mean, there is a space character, so one character is here and there, but you see 105, 120, so 106, 121. Okay, so those two are same. And then there was 199 and 10, so it split this 210 into 2 199 and 10, so it is like 209 and one space character, so total 210. So that is how it is doing the splitting. I hope you got some understanding of recursive text splitter. This is something that we'll be using in our news research tool. Now that you have some understanding of text splitter, let's look into the next step, which is vector databases. Now for vector databases, there are a lot of options, Pinecone, Milvus, Chroma, but we are not going to use them in our project. We will use something called Phase, which is a kind of like a lightweight in-memory vector database type of thing. FASE stands for Facebook AI Similarity Search. It is actually a library that allows you to do faster search into set of vectors that you have, but it can be also used as a vector database if your project is smaller and if your requirements are kind of lightweight requirements. Okay, so you can read about FASE, but I will give you a very quick understanding. So what will happen is, once you have a set of chunks that you have created using recursive text splitter for our project, we will convert those into embeddings. See, embedding conversion is a must-have. We can use either OpenAI embedding, Hugging Face embeddings, Word2Vec. There are so many embeddings out there in the world. Based on a problem statement, we can use any of them. And then we will store them into a vector database. So if we are using Pinecone or Milvus, we would have stored these into that proper vector databases. But for our project, we are just going to store them into phase index. This is like an in-memory structure which can do a faster search on your vectors. So let's say if you have an input question called what is the price of H100 GPU, we will again first convert that into a vector using the same embedding technique, and then we will give it to phase index. And what phase index will do is, let's say these vectors that we have created out of these chunks are, let's say I have 1 million vector. Phase will efficiently perform a search for a given vector, and it will tell you out of those 1 million how many of those vectors are similar. Okay, and this I have explained in detail in this particular video, which I'm going to provide a link in a video description, so please watch it if you haven't seen that. But let me just quickly show you how phase works by using some simple code. So you have to first install these two libraries. Okay, and once these libraries are installed, I'm going to import pandas, and I will just increase the pandas data frame column width. I'll explain why I'm doing that later on. But I'm loading a CSV file which has like 8 records, so different 8 text and their category. They are either health, fashion, these type of categories. So I'm loading that into a data frame here, and my data frame shape looks something like this, and my data frame looks something like this. Now I will convert these text, okay, these 8 sentences into vectors, and the way I'm going to do it is using the sentence transformer library. So I will say from sentence transformer import sentence transformer. Okay, and for this sentence transformer, I'm going to use a model or a transformer entity called this all MPNet. And if you want to read more about this, you can just say Hugging Face sentence transformer. You can do reading and you can kind of figure out how it works. But in simple language, all they're doing is converting this text into a vector. So how does it do that? So I will just say encoder is this, and then encoder dot encode. Okay, and that encode expects an array of text. An array of text is df.text. See, df.text, when you give it, it gives you that entire column, and that you can store in the vectors. And let me just print the vector shape. It might take some time, by the way. If you're running for the first time, just have some patience. You can see that there are total 8 vectors. If you see this, it's like a 2-dimensional array. Okay, so first one is this, second one is this, third one is this, and so on. So meditation and yoga can improve mental health. The vector corresponding to that is this one, and you see dot dot dot. So the total size of one vector is 768, which I'm going to store it in a variable. So see, so vectors, if you do vector dot shape and 1, so this is the size of each vector, and we have total such 8 vectors. I will store this into a parameter called dimension, because that dimension I'm going to use later on. And then I will import the phase library. Okay, so once phase is imported, I will call index flat L2. So this is the index that uses a Euclidean distance or L2 distance. Okay, so that's the index that we are using. Once again, if you want to know more detail, you can go to either face.ai or go to their GitHub page. You can do more reading, but as such, it is very simple. It is just creating, similar to a database index, it is just creating an index that allows you to do faster search later on. Okay, so here I can supply them actually, and that will be my index. So I'm creating an index of size 768 here, and when you print that index, you'll see nothing. It just created some empty index. Now in that empty index, I can add some vectors, correct? So when I added it, now my vector is kind of ready. So going back to that picture again, we have total 8 vectors, right? Total 8 vectors, and the size of each vector, the size of this particular array is 768. We are just adding that into face index. Now face index will internally construct some kind of data structure. What that data structure is, that is out of the scope of this video, but some data structure that allows you to do fast similarity search. So for a given vector, we can find, okay, out of these 8 vectors, which 2 vectors or which 3 vectors are similar. Okay, so here now, once I have index, I can do index.search, and here I want to supply search vector. But what is the search vector? Well, we don't have search vector ready, so I will give some input search query, and the search query is, let's say I want to buy a polo t-shirt. Okay, and that search query we have to, of course, encoder.encode. If you look at that picture, we need to kind of convert this into a vector. So that is what I'm doing here. When I say encode my search query, and I get the vector back. If you look at the vector shape, see, it's a simple array 768, but this search vector expects 2-dimensional array. So I'm going to use NumPy and convert this vector into 2-dimensional array. So it's simple, folks. What I did is something similar to, I put, let's say, vector into an empty array outside. So it was 1-dimensional array 768. Now it become 2-dimensional. And if you print that, see, vector was simple, 1-dimensional array. But if you look at this as vec, now it is same vector, but see, there is one outer array outside that, and the reason is this particular function expects that format. Okay, okay, some argument is missing. How many similar vectors do you want? This is like kth nearest neighbor. So let's say I want 2 similar vectors, and it gives me these 2 vectors. Okay, so it returns a tuple, and the first one is the distances, the second one is the index in our original data frame. So in our original data frame, locate the rows which has index 3 and 2. Okay, so which one is 3 and 2? So 3 and 2 both are articles related to fashion, and you can see that I want to buy a polo t-shirt is kind of similar to fashion. Okay, so that's what it did. I can store them in distances, and I can store them in tuple. And if you look at I, right, 3 and 2, you can locate that using df.loc. So if you do df.location and do 3 and 2, it will give you those articles. And if you want to be kind of like in a programmatic way, you can do it similar thing. So I of 0 is 3 and 2 only. Okay, so that's what it is giving you. Now, one thing you might have noticed is in this text, okay, let me print the text here, search query. So in this text, I want to buy polo t-shirt. See, the exact word is not present here. See, so this is not like a keyword search. This is a semantic search, which means it is capturing the context or the meaning of this sentence and giving you the similar sentence here. If you look at our entire data frame, see, it has meditation and yoga and all that, but it gave you only fashion related articles. You can change a sentence. So let me say that an apple a day keeps the doctor away. Okay, and I will go here and I will say run all the cells below this particular cells. Okay, I think there is some problem. Okay, let me run all the cells here. You notice that when I say an apple a day keeps doctor away, the search results were related to health. Once again, you will see that in the similar vectors, which are these two, the exact words are not matching. See, an apple day keeps the doctor away. It is not present in any of these sentences. But if as a human you have to think which are the two similar sentences for an apple a doctor keeps doctor away out of all these 8, you would probably give these two, because we are talking about health here and it gave me the health related articles. Okay, you can try something else, which is looking for a place. So let's say looking for a place to visit holidays. Okay, and go to cell, run all, and you notice once again it gave you 2 articles which are related to travel. So I'm going to provide all these individual notebooks, by the way, in the video description below. So just check it, just think about it, and you will get an idea. So this was just a quick demo of Phase Library. This is something that we will be using in our news research tool project. Let us now discuss the retrieval QA with sources chain. Once you have stored all your vectors in a vector database, the next component will be asking a question and retrieving all the relevant chunks. Let's say my relevant chunk is chunk number 2 and chunk number 4. Using these chunks, I will form an LLM prompt. The prompt will be something like, I have H100 GPU, what is the price of it? Give me the answer based on the below text, which is chunk 2 and chunk 4. And then LLM will give you the answer. The benefit of this is you can tackle the problem of the token limit and also save some bill on your OpenAPI calls. So now when you think about combining this chunk, see here what we did is whatever chunk you get, you put all of them in one single prompt. Now, as a result, here I got chunk number 2 and 4, but actually I might get more chunks. Let's say I got 4 chunks and combined size of these chunks is more than the LLM token limit. So then that is the drawback of this method. This method is called, by the way, stuff method. So you're getting all the similar looking chunks from your vector database. Then you're forming a prompt. And when you give all these chunks together, it may cross that LLM limit, token limit. So that is a drawback of this method. If you know that chunks will not cross LLM token limit, then it's fine. The stuff method will still work. It is the simplest of all. But the better method, especially when the combined chunk size is bigger, is map reduce. In map reduce method, what we do is we make individual LLM call per chunk. So let's say I have these 4 similar chunks. So for my question, let's say what is my H100 GPU price? Give me the answer based on chunk 1. Then again, I'll ask a question. What is the price of H100 GPU size? Give me the answer based on chunk 2, chunk 3, chunk 4. So you are asking 4 different questions, and each time you pass different context, which is chunk 1, 2, 3, and 4. Obviously, you get 4 answers. Here there is a typo, by the way. This is FC1, FC2, FC3, and 4, and so on. So this is like a filtered chunk or an individual answer. And then you make a 5th call and you combine all these answers together. And you say to your LLM that out of all these 4 answers, just give me the best answer, or just combine all these answers together and give me the final answer. This way, you will tackle that token size limit. But the drawback here is you are making 5 LLM calls. See, 1, 2, 3, 4, and 5. In the previous method, you made just 1 call. So that is always a drawback. So now let's do some coding and try to understand this thing in a little deeper fashion. I have imported all these necessary libraries. You need to give your OpenAPI key here. Okay. If you create a free account, they give you like $5 free credit. So you can use that. And after this account is created, you get that key. Okay. We have covered all of that in our Langchain crash course. So here I will create an LLM object. And then I will use unstructured URL loader. This is something, folks, we have already looked into it. So I will not go in the detail here. I'm just loading 2 different articles. So first article is on Tesla. Okay, Wall Street raises Tesla, whatever. And the second article is on Tata Motors, which is India-based automotive company. And here we are loading both of these articles into our data loader, and then we are using the same recursive text splitter which we have looked into before and creating these individual chunks. So we created total 41 individual chunks. I mean, you can check the individual chunks here. See, this is the page content. Okay, 0, 1, 2, 3, 4, whatever. You can check it out, right? Like 9. And then once that is done, you will create Open API embedding. So how do you do that? Well, see, we created this particular class here. So I will say embeddings is equal to Open API embeddings, and then you will use the face class that we imported here and call a method called from documents. Now see, from documents method in face will accept the documents or the chunks that you created here, and then it will take another parameter which will be your embedding. So here I'm using Open API embedding, so I'm giving that. You can use Hugging Face or any other embedding too, and the resulting index will be this vector index which we have. And once you have that vector index, so I'm not running this code, by the way, because I already ran this code and I have saved this vector index into a file. Okay, and the way I saved it is I can use this code. See, you have vector index, and then vector index you can write it to a file called vector index pickle file. So previously, before shooting this tutorial, I already ran this code. I saved vector index into a file, and let me show you that file on my disk. See, vector index.pickle file. So this is sort of like a vector database. It is a vector database which I have saved as a pickle file on my disk, and now I can load that pickle file by running this code. See, now I can run this code and my vector index is loaded into a memory. So this vector index now have knowledge of both of these articles. Now let's create a retrieval QA with sources chain class object. The first argument that it expects is LLM. So wherever we created our LLM, which is here, you know what, just to, okay, I'll just put that in here. And the another argument is retriever. So retriever is basically how you're planning to retrieve that vector database. So vector database you can give as an argument here, and you can just say as retriever. Okay, this is just a syntax that we're using, and this thing we are going to call it a chain. Okay, here I need to say from LLM, and you will see that it has created this chain, and in the chain you will see interesting prompt which might get you very excited, which is this. See, use the following portion of long document to see if any text is relevant to the answer of this question. This is the thing we have discussed before. Now we are going to ask some sample question. So my sample question is, what is the price of Tiago ICNG? And if you look at the article, the Tiago ICNG price is between this and this. So you would want this particular answer from our code. Okay, so that is my expectation. I will enable the debugging in Langchain so that I can see what's going underneath, and then you will say chain. In the chain, the question that you want to ask is this, and this is the argument that you give. Okay, so now let's run this code and see what happens. So this will kind of show you some internal debugging. So when I said what is the price of Tiago ICNG, first it retrieved the similar looking chunks from my vector database. So there are total 4 chunks, 1, 2, 3, and 4. Okay, and the question is same for all of these. So see, the chunk is the company also said it introduced Tiago. See, my actual answer is ready in first chunk itself, but it will still retrieve 4 most similar looking chunks. Now see, this is also similar looking, but my answer is not there exactly. This is also similar looking and this is also similar looking. Okay, all this code is available in the GitHub, by the way. You can run it and you can just go through it yourself. So that is step number 1, which is chunk 1. And then you combine a question and you ask 4 questions, individual questions to your LLM. So all these questions will go to the LLM. So my first prompt is, use the following portion of a long document to see if any of the text is relevant to the answer of these questions. Right? Return any relevant text verbatim. And this is the paragraph that you give. Okay, similarly, this is the second question, this is the third, and this is the fourth question. So these are the 4th questions. So you passed all those 4 questions to LLM. So there are 4 LLM calls. As a result, you will get 4 answers, correct? So let's see the 4 answers now. So the first answer is this, the Tiago ICNG price. So you know this is the final answer, but still it will generate 4 answers. So this is the first answer. This is the second answer. This answer doesn't look good, but it will still give you some answer. This is the third answer and this is the 4th answer. Okay, so FC1, FC2, 3, 4. These are the 4 answers that it gave. Now you will combine those 4 answers in a summary chunk and give one more call to your LLM. So where is that question? See, these are the four answers. Okay, 1, 2, 3, 4. Now here is the combined summary. What is the price of CNG? So the summary is content. See, 4 answers are combined. So given the exit prompt is given the following whatever summaries, give me the final answer. Okay, and then in the end it will give you a final answer, and the final answer is the Tiago ICNG price is between this and this is the source reference. Okay, so once again it is using this map and reduce method. I have given this notebook with a lot of comments, so maybe you can read it and get an idea. But overall, now what happened is we looked at all the individual components. We started with text loader, splitter, phase. We talked about retrieval just now. Now we are going to combine all these pieces together and build our final project. Our final project is not going to take much time because all the individual pieces are ready. We have also understood the fundamentals behind the scenes. See, learning only API is not important. You need to understand the fundamentals, how it works underneath. Then only you can become a great data scientist or NLP engineer. So far, we have cleared all our fundamentals. Our individual pieces are ready. We need to just assemble them and it's not gonna take much time. I'm super excited to move on to the next section now. And this is the argument that you give, okay? So now let's run this code and see what happens. Now we are going to use all the components that we have built so far. We will assemble them and build our entire project. I have this directory where I will be keeping my project. In the notebooks folder, you will see all the individual notebooks. And here outside, I will do main project coding. Right now, you're seeing 2 files, requirement.txt and .env file. If you look at requirement.txt, it has all the libraries which we are using. So you can run pip install -r requirement.txt to install all the libraries. In the .env file, I have OpenAPI key. So you will put your own key here, which you have got by getting that $5 free credit on OpenAI, or if you have paid account, just use that. Now let me create a main.py file here. So I will say main.py, and here I'm going to import all the necessary libraries. So since the list is pretty long, I'm just going to copy paste it from somewhere. And the very first thing I will do is load that OpenAPI key. Now, so far we were using os.environment variable, but that's a little clumsy way of doing it. There is a better way, which is using the .env Python module. So if you look at this particular Python module, you have to install it first of all, and then you can just use these 2 lines. And I'll tell you what they do actually. So here, it will take all the environments variables from .env file and it will load them into the environment. Okay, so if you look at let's say env file, .env file is this, so it will set domain environment variable as this, root URL as this, and so on. Okay, so it's just one call, and within one call we have loaded our API key, and the API key is not visible in the code. So it's kind of like a cleaner way, it's standard practice that people are using nowadays for loading this. Now let me just write some basic UI. So I will say st.title. Okay, our title of the application is news research tool, so that's what I'll say here, and then I will create the sidebar. So if I were to show you the UI of the our tool, it will have on the left hand side, it will have this kind of three URLs, URL1, so this is URL1, this is URL2, this is URL3. I will have process button below it, and the title that I'm putting is here, it will be visible here, and here I will have on the right hand side the actual question, and below that there will be an answer. Okay, so in the sidebar I'm going to say sidebar title, news article URLs. Let's say that's my sidebar title, and I will have three URLs. So I will say for I in range, let's say 3. Okay, and st dot sidebar dot text input. So I will take the URL from text input, and I will use a format string here. I will say URL I plus 1 because it starts with 0. So I'll say URL1, URL2, and URL3. Okay, and below that there will be a button. So the button will be called process URL maybe. Okay, and when you click that button, that value I will get in process URL clicked. And when I say process URL clicked here, when I press that button, the flow will go here. Okay, let's just run whatever we have so far and see what happens. Okay, so the way to run this is streamlit run main.py. When you run that, it will show you this kind of UI. See, 3 URLs. There's a news research tool here. We'll add the question box, but here you can add those URLs, and when you hit this button, process URL button, actually the flow will go to this if condition. Okay, so let's write some code inside this if condition. So here we will use the unstructured URL loaders, and we will get all the URLs. Now here you need the URLs, right? So where are my URLs? So let's say I create this URL variable, and those URL you can build that array here. So whenever you enter that URL, it will come to this array, and that array is passed here. Okay, and that is called loader, and you do loader dot load. Okay, this should be very apparent to you. So this first step is loading data. After you load the data, you all know next step is splitting the data, and for that you will use recursive character text splitter, which has 2 arguments, I guess, separators and chunk size. I'm not worrying about chunk overlap that much, although you can play with it. So this is my text splitter, and I will say from text splitter split my documents, and my documents will go here, and I will get the individual chunks. Okay, and those chunks I will then do embedding. I'm going a little fast because we have already covered all these things before. Create embeddings, and okay, let's say create embeddings. Okay, so these are the embeddings I have, and then you will say face from documents, and the first argument is documents, and the second argument is embeddings. Okay, and save it to face index, and we'll call this particular variable, let's say this. Okay, and then we are going to save this in-memory phase index that we have on disk. So we'll save it in a pickle format. And here is how you save it. The file path is going to be, you can give any file name. Okay, so I'm just going to give, let's say, phase store OpenAI pickle. Okay, so that is stored here. And just to show the progress, when we are processing the URL, so let me just show you the UI here. When you enter a bunch of URL here, process URL here, like below this news research tool here, I want to show a progress bar. So progress bar will say, okay, loading the data, splitting the data, things like that. And for that, we have to use a main placeholder. So I will say main underscore placeholder is equal to st.empty. So this way you are creating an empty kind of like UI element. And when you are loading the data, you can say dot text and you are saying, okay, data loading started. Okay, so I will just again copy paste here and I will put this kind of progress bar before, I think, split document and also here. All right, so far I think my code looks good. I can rerun this and see how it goes. So I'm gonna rerun. So you can click on rerun or just place R button. So my code is rerun now, and I'm going to give these 3 articles here. So this is my first article, then this one is my second article. So first, second, and the third one is this. All 3 are articles related to Tata Motors, and see, it will say data loading started. So now it's loading, going to these 3 URLs using unstructured URL loader, loading the data. Then it is splitting them into 1000 token chunks. Then it is building embeddings using OpenAI API calls, and then it is using phase to kind of build an index and save it to a disk. So when you look at the folder that we have, you will find this file, phase store OpenAI pickle. This is like our vector database. So now our vector database is ready. So next step, we will enter a question box here. Okay, so let's do that coding now. I'm going to say main placeholder dot text input, and the text input will have question, and whatever query you are getting, that question, you will say if query. So when you type in a question, hit enter, it will come here. Now what should be the first thing that you'll be doing here? Well, you will be loading the vector database. So you'll say, okay, if the file exists, there could be a reason where this particular file doesn't exist. So you want to make sure you're doing that check. If the file exists, then you need to read that file. So you'll say with open file path read, it's a binary file, as f and pickle dot load. So you load that file and you call it vector store. Okay, we are using the Python's like pickle module. You can see here we have imported that, and then we are creating the retrieval QA chain. Okay, so vector store is here. This QA chain expects LLM as an input, so I don't think we have created LLM. So let me just copy paste it here. I have the code ready here so that I can save time on the recording. So I have created LLM object now. My chain looks good, and then in chain you will say what is the format. So you supply a question here. Okay, this particular argument you will supply as true, and then you will get your result. Now result will be a dictionary which will have 2 elements. Okay, so result will have, it will look something like this. So it will have answer, and it will also have whatever is the answer. So it will have whatever is the answer, and it will also have sources which will contain the URLs or whatever. It can be an array. So result answer contains answer. We need to display that, right? So st dot or main placeholder dot, you know what, I will just use st dot header here and say here is my answer, and then st.subheader, and that subheader will have result answer. Okay, so let's try this much so far. So I'm going to bring that UI here, click on rerun, and it just reran. And I will ask now, what is the price of Tiago ICNG? Okay, so this is the question based on those three articles. If you look at that article here, I think it is here, see, ICNG's price is 6.55 to 8.1, and see, it is giving the answer properly. I want to also see the source, like from which URL it retrieved the article. So we can do that real quick here. Just to save time on recording, I'm not going to go too much in details because this is very minor. So you are basically going to result and get the sources element from the dictionary, because in that dictionary this might not be present. Okay, this may be present, this might not be present. That's why I'm calling get argument. And if it is present, then you are creating another subheader and providing sources list. Now why list? Because sometimes answer may come from multiple URLs, so you need to handle that scenario. So let's bring this code here now, rerun this and ask the question again. See, Tiago CNG's price is this, and here is the URL. So if you look at this URL, it will have the answers. Correct this. Now you can ask a summarization question as well. For example, I have this article, KR Choxis, and I want to just summarize this article. This is their recommendation on this talk. So I will say, can you please summarize this article? Okay. And by the way, this is like bold. So let me just change this thing. I'm just going to call it right, because that way it is not bold. Okay. So here you see it already summarized the article, and it also gave the source for that. But this is like little bigger font, so I'm just changing it to smaller font. But overall, folks, this tool is ready. Now it's going to be very useful to my equity research analyst, my Peter Pandey, who is investing on Rocky Bhai's behalf, because now you don't have to read so many articles. Whatever question you have, you can ask it to this news research tool. It will not only give you the answer, but it gives you the sources references. This is very important, folks. And by the way, with LLM boom, many clients are building this kind of tool. How do I know it? Well, my own company, Inatlic Technologies, we have some US based clients for whom we are building these LLM projects. And this is a real life use case that I'm showing you. So this is not like a toy project. It is based on a real things which are happening in the industry. Document summarization, building chatbot similar to ChatGPT on custom data. So this is sort of like we build a chatbot which can answer your questions on custom data, which is these three URLs. So we just built the basic proof of concept, and it is already working. Code, everything is given in the video description below. So please try it out. Long term, we have discussed this, like long term, when you're building this project in the industry, you will build two components. One is data ingestion system, where you will write some kind of web scraper that goes through all these websites, and it retrieves all those articles. Now for web scraping, you can use native Python or Bright Data. Even unstructured URL loader will work, but it might start not working at some point, because websites will detect the scrolling activity and they might block you. That is the reason why people use tools like Bright Data, which is a proxy network based tool. Then you will create embeddings. It could be OpenAI, Hugging Face, and store it in a vector database. So if I'm doing this in the industry, like a big project, I will not use Face. I will use vector database. I can still use Face as a library, but otherwise I'll use a vector database. And once you have data in the vector database, you can build UI in React or whatever tool, and then call that vector database to retrieve the similar looking chunks and post the answer back to chatbot.
Data, data, data. Data lights me. I can't avoid it.
In today's video, we are going to build end-to-end LLM project where we are going to use all these technologies. Atlic Tees is a store that sells t-shirts. Their data is stored in a MySQL database. We will build a tool similar to ChatGPT where you can ask a question in natural human language. It will convert that question into SQL query and execute it on our database. You will get a feeling as if you are talking to a database in a plain English language. It's gonna be a very interesting project. Let us discuss project requirements. Our Atlic Tees t-shirt store sells 4 brands mainly: Van Heusen, Levi's, Nike and Adidas. And the MySQL database has first table which is called t-shirts where we maintain the inventory count. So basically Levi's black color small size t-shirt have 15 stock quantity left. Okay, so 1564, these are the stock quantities, and this price is price per unit. So one Levi's black small size t-shirt will cost you $19. The second table I have is discounts. So for example, t-shirt ID 1, which is Levi's black small t-shirt, has 10% discount. In real life, the database will have so many different tables. To make things simple for learning, I'm just going to use 2 tables. The t-shirt store manager is Tony Sharma. Whenever he has questions related to stock quantity, discounts and so on, he uses a software which is built on top of this MySQL database. If you look at retail domain overall, they will have these softwares where you can use various UI options on the software to get answers of your questions. And Tony is fine using this software, but many times what happens is he has custom questions, little complex questions, and the software can't figure it out. So then he will have to download the data in Excel, do certain things manually. Whenever he's busy, he goes to Loki Lal, who is a data analyst working for this company. And Loki knows SQL. So let's say if Tony asks this question that how many white color Nike t-shirts do we have in stock, and he will just simply run the SQL query on that database and get the answer back to Tony Sharma. But Loki is busy as well. He's busy building Power BI dashboards and he doesn't have too much time for these ad hoc queries. Also, Loki is the only data analyst working for this company, and Tony sometimes have issues where Loki is out on leave and he's not available, and then he has to do all this work manually because Tony himself doesn't know SQL. So then he goes to a data scientist who is working for the same company, and you might guess what is the name of that data scientist. Well, Peter Pandey, who looks somewhat like me, and he says, "Hey Peter, buddy, we are living in ChatGPT era, LLM, Langchain, all these cool frameworks have come up. Why don't you build a tool similar to ChatGPT where I can ask a question in a human language and it somehow converts that to a SQL query, executes it on a database and gets me the answer, that the answer is 3165. Peter likes this thought and he agrees to build this particular tool. So let's look at the technical architecture of this tool. Whenever you have a question, you need to convert that to a SQL query using some LLM. Now we are going to use Google Palm here, which will do this conversion, and we will use Google Palm from Langchain framework. Within Langchain framework, you can use Google Palm and other type of LLMs. We will use a SQL database chain class within Langchain framework. This will work okay for simple queries, but as the queries get little complex, out of the box, Google Palm model will fail sometimes. It will give errors, and we need to do some spatial handling. We will use a concept of few shot learning here. Few shot learning means you need to prepare the training data set where you have a sample question and a corresponding SQL query. Here you will list down all those queries where out of the box Google model is failing, and you can prepare these queries with the help of your data analyst, Mr. Loki Lal, and you prepare this data set. It is called few shot learning because you don't need to prepare like 1,000 samples. You can have some few samples here, and then you will convert this training data set into embedding vectors. If you don't have any idea on what is word embedding, sentence embedding, go to YouTube, search for code basics embedding or code basics word embedding. You will find a couple of videos where I have provided very simple intuitive explanation.
For these embeddings, we will use Hugging Face library. Once embeddings are created, we will store them into a vector database. When you think about vector database, there are a couple of options that you have: Pinecone, Milvus, ChromaDB, Face, etc. We are going to use ChromaDB. It is open source and it will work perfectly okay for our project. Once the vector database is ready, we will pair it up with Google Palm LLM. We'll use few short prompt template to create the SQL database chain. And the last piece will be building a UI in Streamlit. We will write just few lines of code, 5 or 6 lines of code, and our UI will be ready. To continue further on this project, obviously you need to have Langchain basics clear, for which I have this particular video where I have covered all the basics in this one single video. So make sure you have either watched it or you already know the Langchain fundamentals, just the basics. You also need to know what is vector database. In this 6-minute video, I have given a very simple explanation of what is vector database. So if you have not seen it, please see that. Now let's do a review of Google Palm. There are 3 popular options when you talk about building LLM application. OpenAI's GPT-4 model, which is best in the market, but it is paid. The other 2 unpaid are Meta's Llama and Google Palm. I could have used Meta's Llama for this project, but you have to download that Llama model locally or less in your Google Colab, and it is very heavy. Like sometimes it's the size is in gigabytes, and it's kind of little bit hard to set up. Whereas Google's Palm is very easy to set up. It works similar to OpenAI API, where you just make a query to their Google server. And the beautiful thing here is it is all free. Okay, so we are going to use that. As a next step, we are going to set up API key for Google Palm. I have opened makersuite.google.com website where you can log in using your Google account. You need to go to get API key and you can create API key in your existing Google Cloud project. And if you don't have that, just click on create API key in a new project. So here I will use just any project and create an API key. Now this API key is sort of like a password, so make sure you don't share it with others. I'm showing you this API key right now, but I'm gonna delete it after I use it in my project. So I'll copy it, save it at a safe place so that I can use it later on in my code. Talking about Maker Suite, it gives you a test pad where you can try different prompts. For example, text prompt. Let's go here, and here you can write different prompts and it will use this text bison model. Google Palm is the architecture, but the specific model that it is using is text bison. The creativity parameter means if it is more closer to 1, then it will be more creative. If it is more closer to 0, it will be less creative. You can try some sample prompts. For example, summarize a paragraph, and when you run it, it will summarize the paragraph. You can try poem writing or write your own custom prompt. Behind the scene, it is using the same API that we will be using in our project. Therefore, if you want to quickly test your API, this test pad allows you to do that very easily. You can play with different prompts, but as far as API key is concerned, we are all set now. We will set up our MySQL database now. I have launched MySQL Workbench by going here and typing MySQL Workbench. If you're not aware about MySQL, don't worry. You can go to YouTube, type code basic SQL tutorial. I have this 1.5 hour tutorial where I have given a complete idea for any beginner. So you can follow that and learn MySQL easily. This tool is, by the way, free. You can download it easily by going to Google, searching for MySQL Workbench. I will open this local instance. And if you check video description below, I have given you all the code files. This will have a database directory. You can go here and drag and drop this SQL file here. This file is taking care of creating database and tables within it. You can click on this execute icon and it will create the tables and data within it. When you click on this refresh icon, that's when you will see Atlic t-shirt database. You can right click on it and set it as a default data set if you have not set it like that before. So it just says set as a default schema, and you will see that this font will convert into bold. Now table wise, we have first table, which is t-shirts. If you click on this third icon, you will see some sample record. For example, t-shirt ID 1 is Van who sends red color t-shirt in small size price of one t-shirt is $15, we have total 70 t-shirts available in our store. That's a stock quantity. If you talk about discounts, t-shirt ID 1, which is the same Van Heusen red color t-shirt, has 10% discount. What it means is the $15 is the original price, 10% of 15 is 1.5. So when I sell this one t-shirt, I'm gonna give $1.5 discount to a customer. So they'll get it for $13.5. These records, by the way, will be different when you execute this SQL script because we are using some random numbers here. So don't worry if you don't see the same exact numbers in your case. They are likely going to be different. All right, our database is set up. Now let's start coding in our Jupyter notebook. I ran Python-m notebook to launch my Jupyter notebook. And here I have created a new Python notebook. I'm going to import Google Palm model from Langchain.llms. Okay. Now you can use OpenAI, all kind of models. Google Palm is free. So let's create an object for this LLM, and here I'm going to pass Google API key, which will be stored in a variable called API key, and I will initialize that variable here and add my specific key here. Folks, as I said before, please use your key. I'm going to delete my key later on, so code will not work if you use my key. Once LLM object is created, you can ask some sample prompt. For example, write a poem on my love for dosa. Dosa is a South Indian food. I love that. And you can, print a poem on that. And you see, it is working good. Now, folks, before you run this code, make sure all your libraries are installed. So you can run this command pip install -r with requirement.txt file. And if you look at the requirement.txt file, it has all these requirements, Langchain, ChromaDB, all of that. So I'm assuming you have installed all of that. All right, now let's create an SQL database object. And for that, you can import this particular class. And when you create SQL database object, you will say from URI. Okay, and here you are going to pass a URI. A URI is like URL. It specifies what is your database, what is a host, username, password, and so on. So we'll store all this information in different variables. My database is running locally, therefore localhost. Username, password is root, and @_t-shirt is a database name. See, you see it here. Okay, now the way URI is formed is using this syntax. I'll just copy paste to save time on recording. You don't need to remember all these things anyway. So this is the syntax of it. All right, and then the second parameter is sample rows in table. And I'll show you what this number 3 means. So here, the result that I got, I will store it in this variable called db. And this will have a property called dbinfo, which we can print. When I do this, I will get a confirmation that I am able to connect to my SQL database from my Jupyter notebook, and see, it is able to pull all this information, which means my Jupyter notebook is now connected to my database. Now we are ready to create our SQL database chain. Okay, so in Langchain there are all kind of chains like SQL database chain, and for different type of use cases you will have these different chains. So this SQL database chain, if you notice, is imported from Langchain experimental module. Now if you are seeing this video in the future, it is possible you can import it directly from a Langchain module, but as of right now it is part of the experimental module. In the future, if they make it available, just remove this thing, use your common sense, and you should be able to run it. Now let's create the chain object. Okay, and this chain object will take, first parameter will be LLM that we created, Second one is the DB object. See this particular DB object. And then you can store this into DB chain. And now you can run a simple query. Before I do that, I will pass one more parameter, verbose true, so that I can see the SQL query that it is generating and I can see some internal details. The first question I'm asking is this. Okay, let me just copy paste here. How many Nike white color extra small size t-shirts do I have? And let's store it in this UNS variable, control enter. Okay, this is happening because here I need to use from LLM. See, it pulled a right answer. It is saying 59. And if you look at this query, the query that it generated, if you run it, it is actually the right query that it generated. Okay, so here, let me see. So here I can run that query. See, 59. If you just look at Nike t-shirts overall, or let's say, let me just do star here, only Nike t-shirts. See, Nike t-shirts are this. If you look at Nike white t-shirts, this much, and in that extra small size t-shirt quantity is 59, and the answer that it is giving is 59. If you do QNS1, see, it is giving 59. By the way, it is giving a dictionary as an output. If you want to get directly 59, here you can use run. So when you do that, QNS will have the direct answer. Now there are a couple of observations I have. LLM is actually doing pretty good job because I said extra small size, and it is smart enough to figure out that extra small means excess, and it is able to map that to size column. When I say white color, W is small, but it is able to map it to capital W because it looked into our database and figured that our color starts with a capital letter. So you see, this is the power of LLM. Now, this was relatively simple query. Let me try a different query. And the query is, what is the price of the inventory for all my small size t-shirts? Now, while it executes this, let me run that code here. So we want to get all small size t-shirt. Okay. So here I will say where small size. Okay. Let me get all small size t-shirts. These are all small size t-shirt. And what is the total price? Total price will be price into stock quantity. So here I need to run sum. I will say sum price into quantity. Okay. And when I run that, it is actually stock quantity. So when I run that, this is the price I get. Now let's see what we got in our notebook. 215, wrong answer, folks. So why did that happen? Let's just think about it. So here the problem is it said sum of price. It did not say sum of price into stock quantity. It forgot to multiply it by quantity. If you think a little bit, you will actually find an obvious reason. LLM is thinking that whatever t-shirts I have, so let me show you these t-shirts. It is thinking that the price column is for all the t-shirts. So for Levi white color small size t-shirts, I have total 51 t-shirts available, and the price of total price of all 51 t-shirt is 13. That is what LLM is thinking, because the column name is not price per unit, it says price. So price could be total price or it could be price per unit. It is assuming it is the total price. And if this was a total price, then the answer that LLM gave would be correct. But in real life, database column names are not going to be perfect. So this is representing a real life scenario. Okay. So the conclusion that we get is LLMs will make mistake, and we need to tell it somehow that the price column is price per unit. It is not the total price. We can do this using few short learning. We will do that after some time. Let me run a few more queries, okay? And meanwhile, I will store the right QNS answer, okay? And the way you can do that is you can actually run the explicit query. So the explicit query that we have is this, okay? So I'm going to run that query here. So in dbchain.run, you can actually run the explicit query, and we got this right answer, which is stored in my QNS2. All right, so far it is looking good. Now I will run the third query, which will be little bit complex. So I'm saying, if I sell all my Levi's t-shirt today with discounts, how much revenue my store will generate? Now when you want to apply discounts, you need to do some kind of join, okay? So you have all the Levi t-shirts, okay? So these are all the Levi t-shirts that you have. You need to multiply price by stock quantity, and then you need to sum all of this. You will get total revenue. Then you need to go to discount table and figure out on Levi's t-shirts how much discount you have. For example, one of the t-shirt ID for Levi is 3. Levi white extra small is 3. And for 3, we have 20% discount. So on this price of 44 into 94, you need to apply 20% discount in that. So let's see if LLM can handle this kind of complex case. No, so it failed. It failed because in the query, now you see all these columns: discount.start date, discount.end date. Usually, whenever you have discount, you will have start date and end date column, because discounts can't run forever, right? There will be start date and end date. But in our database, if you look at discount table, we don't have start and end date. So LLM is using its general knowledge, and it is assuming that there will be start date and end date in our table. We need to tell it that, hey buddy, don't use your brain, okay? Look at the table, and if you find a column, then only use it. Here start date doesn't exist. How come you just use it, you know? So we need to tell that. And again, we will do that using few short learning after some time. For now, let me run that query explicitly, okay? So here, this is the query to get the answer, and we'll run it. And by the way, this is not a MySQL tutorial, so I'm not going into detail. But let me just very quickly explain how this thing works. So here, if you look at this particular query, it has, this part is a subquery. And if you execute this query, it will pull all Levi's t-shirt, it will multiply price by quantity, and it will give you that. So for t-shirt ID 17, if you sell all the t-shirt, you will get this much revenue. For 64, you'll get this much. You can sum them up to get a total revenue. And then you need to make a join of this table with discounts table. See, this query, by the way, the result is stored in table called A, and you are doing a left join with discount table, and then you are applying the discount here. So if you execute this, this is actually the answer, okay? 24,367. And if you look at this, 24,367 is the answer we got, which we have stored in this QNS3 variable. Similarly, let me run a few more queries. So this is, if I sell all Levi's t-shirts, you know, how much revenue will I generate? I will generate this much. And another question I have is, how many white color Levi's t-shirts I have? Now let's go and figure that out. So you want to know how many white color Levi's t-shirts. So when you say total Levi's t-shirts, it is this much, and white color, right? So you will say and color is equal to white, okay, this much. So total white color Levi's t-shirts are 94 plus 51 plus 29, 15 and 95. But in our code, what's happening is, see 94, 15, 1, it pulled all that numbers, but it did not sum it up. So if you look at the answer is 94. Why it did that? Because it is not able to figure out that it needs to do sum here. Okay, so the right query here is sum of stock quantity. So that will be 284. That's the right answer. Again it failed. So what do we do now? Well, we run the query explicitly so that later on I can use it in my few short learning. Okay, so QNS5 query, I will just copy paste whatever I wrote in my SQL workbench, and QNS5 now is 284. So now we have all these answers and we have all these queries. Let's try few short learning so that our LLM can improve on the errors that it is making. In few short learning, the first thing we need to do is provide the question and query pairs where LLM was getting confused. Once we have those training example, the second step would be to convert it into embeddings, and we are going to use Hugging Face for that. So let's go to a notebook and start putting together those few short examples in a simple Python list. And each of these examples would be a dictionary. And dictionary will have one element which will be your question. Okay, so let's say my question is this, and then the SQL query corresponding to that question would be this. So we previously ran all these queries, so I'm just copy pasting just to save time. Other than these two, we need to have SQL result and answer as a parameter. Now, why do we need this? Well, just hold on. We will see this later. This is the syntax that the default Langchain SQL prompt is using. Therefore, we are using the same syntax. I'll show you a little later. And this first answer, if you remember, we stored that into QNS1. Okay, so QNS1 is nothing but it is this 59. Okay, so that's what we are having. So we take all these samples and put them into this single array. And once we have this thing ready, the second thing is we use Hugging Face for generating embedding. And for that, we'll import the Hugging Face embedding class, and we are going to use this particular embedding. Now, folks, there are so many different ways to generate these embeddings. I tried this particular embedding, it was working fine, so that's why I'm using this. You can even try OpenAI embedding if you're ready to pay the price. And there are instructor embedding. In the other project that we did for EdTech domain, we used instructor embedding. So you can use whatever embedding can serve your need, and this will be stored in this particular variable. And let me just, we can say embed query. What embedding will do is you can type any query and it will generate an embedding which is just an array. Okay, so let me save it here. And the example you can use is, okay, let's say we generate embedding for this particular sentence. So this E will be a list of size 384. And when you look at these numbers, they don't actually make sense, but they capture the meaning of this particular sentence in a right way. So that if someone types a different query, I mean, the query is like similar to this, but the words are different, even then the embedding of that embedding of this query will be similar in terms of cosine similarity, of course. So I'm going to remove this, and I'm going to now create a vector database. And for that, we need to create a blob of all these sentences. Okay, so let's say I have this sentence. What I need to do is I need to remove all these keys because they are really not needed. Okay, so I remove all these keys, and then I kind of merge these strings together. So see, I will merge all these strings together and I will generate a single big string with some space in between, like this. And this QNS, whatever that answer, I think it was 51, 59, whatever, right? So I want to generate this kind of blob, and this text block I will vectorize and store it in my database. Now to do that, I can use list comprehension. I can say, for example, in few shots. So this is the array, right? Like few shots, this is the array. I can say example dot values. So I'm interested only in the values, these values, not the keys. So when I do that, I will get this kind of a list, and each of these elements are dict values. I want to generate a string out of it. And how do you generate a string from a list? Well, if you know Python, you can do join of this, and I will say to vectorize is this. See, it generated this list. And if you look at the first element, it is simply taking all these four values and making one big string out of it. Okay, now let's create a vector database, for which we are going to import Chroma. Chroma is the vector database that we are using in this project. And then from Chroma, we can say from text, where you supply the text, okay, the array of text, and the second parameter is embedding. Okay, so embedding is equal to embeddings, and the last parameter is the metadata, which is our few shots. So the entire few shot array that we have, we are giving it to as a metadata. You can go ahead and read the documentation, but the essence of this statement is that this is how you generate a vector store. So this vector store is this vector store. It's already created, and the job of vector store is to take an input question. So let's say if I have an input question like this, it will convert that into embedding, and it will pull you the similar looking few shot example. So let's try that and to see how that thing works. So for that similarity matching, you need to import another class called semantic similarity example selector, and in that you will pass two parameters. So first thing is, obviously you need a vector store. So you will say vector store is equal to vector store, and then k is equal to 2, which means pull me two similar example. K can be 1, 2, 3. I mean, if you want 3 example, just say 3. This I have stored in example selector variable, and you can say select examples. Okay, so you can give is a sentence. Okay, so you can give a sentence like this here, and you can say, can you pull me similar looking things from this? And see, the similar looking question is, how many t-shirt do we have left? So just read these two statement. Okay, this and this, they look similar, and the second based match is this. This is not exactly matching, but this is like a second based match that you can get. Okay, so this mechanism that you give input sentence to vector database, and you can pull similar looking queries. See, if you can pull similar looking queries, then my LLM can look into those, and from those queries it can learn and it can produce a good result. All right, now if you remember, we already discussed giving a custom prompt to our LLM, because our LLM is making mistakes such as discount table doesn't have a start date. It is still using start date in my MySQL query. So I want to have a custom MySQL prompt saying that only use database table columns, right? Do not just make things up. So I want to give some instructions though, so that it doesn't make a mistake. Now I have to write that SQL prompt on my own, but the good news is that Langchain already provides this prompt to you. You can import that prompt by doing this, and if you print that prompt, let's see how it looks. See, you are my SQL expert, Given the question, create MySQL query first. Never query for all columns. I don't want to say select star. I want to say select X, Y, specific columns. You must query only the columns that are needed to answer. Pay attention to use only the columns that you see in the tables below. See, this is important. We are saying we are going to give you the table info and only use, see, table info is this, folks. This table info that you printed. Use the columns only from these tables. Okay, that's what we are saying. Also, if you're talking about any date, use current date for the today. So we are giving a lot of useful instructions, and then we are forming a query. Okay, if you look at the prefix, so let me print that one also. I think suffix. So suffix is like this. Okay, so eventually what we'll do is, see, we'll take our prefix, so prefix is this, we'll take our suffix, suffix is this, and our actual query will come in between. So here, if you look at our prefix, see, prefix has this format: question, SQL query, SQL result, answer, and that is the format we have used here. See, look at these 4 elements. That's exactly the format that we are using. So now let's think about the query, the query in the middle. Okay, what will go in the middle? For this, we need to import a prompt template. Okay, and then that prompt template, folks, just to save again time, I'm just copy pasting things. It will have question, SQL query, SQL result, answer, and the template will be something like this. Okay, so what happens is, actually, when you actually type in a query, this query will have that format. Okay, question will go here, the actual question that you're generating, the SQL query, and so on. Okay, it's I think intuitive. If you've seen my previous videos, you will get some idea. Now comes the time to create our few short prompt template. Okay, and in this few short prompt template, we will pass bunch of parameters. The first one is obviously the example selector that we have created. See, this is the example selector. So if you do this, you will establish the association between your LLM vector database. You will say, hey LLM, if you're confused, look into this vector database. Okay, so that is what we are doing here. The second one is the example prompt that we have created, and then the next two are the prefix and suffix. So now using these three, it will generate this kind of single prompt that you can pass to your Google Palm LLM. And the last parameter is the input variable. Okay, so in the input variable, you'll see things like table info. So table info is this is the table info. Okay, and if you look at our query, see, that is the table info. So here, actually, wherever you see this bracket, here you will actually put that table info. Okay, so you will put all of this. So your actual prompt will be a little bigger. You will say this. See, now you're saying that use the table info. So here I think you said somewhere, right? Info. Okay, see, pay attention to use only the column names you can see in the tables below. So which tables? See, only use following tables. This. So this type of big prompt will be formed when you write this particular few short prompt template. We are going to save it in a variable here. Okay, and then we are creating the same chain. See, we created this chain before. Okay, if you look at this code, remember we created this object, so it's exactly same. Okay, we are doing that here, but now we need to add one more parameter, which is prompt. This is the only additional thing we are passing, so that whenever it is confused, it uses that new information. And now let's give those queries which were failing. So how many white color Levi's t-shirts we have? Okay, if you remember, it was not using sum before. Now it is using sum. So see, it worked. Second query is, how much is the price of the inventory for all small size t-shirts? And previously it was not multiplying it with this quantity. So let me just show you this one. So if you look at the previous query, see, it was saying 215 because it was not multiplying it with the stock quantity. Now it is doing that. See, it is producing the right answer. And it's not like, see, you can give little similar query. So I will say, how much is the price of all the extra small size t-shirts? This is a little different and it will work. It will, see, it will say size is XS, that way. So let's try the most difficult one that we had, which was that Levi's. So instead of Levi's, I'm saying Nikes, and I'm saying after discount, how much revenue will it generate? See, it worked. It said brand is Nike. This is this. You can change this a little bit. When you change the language, it is still doing that semantic search. When we did this semantic similarity example selector, it is doing semantic search. Therefore, you're not passing the exact query which you passed in your few shot. You can pass little different queries as well. So folks, try different queries, and it is possible that for some queries it may not work. In that case, you will take that query and the right SQL query, and then you will add it to your few shot example. Right now I have 5, but if you want to make all kind of queries work, you might have 40 or 50 different type of few short examples. Okay, so wherever it is failing, take a question, take a right SQL query and add it to few short example, and after that it will not make a mistake. All right, we are all set to put all these things together and write a Streamlit UI, which you will see is only few line of code. So we are almost there, folks. Please stay on. You have come so far. I know it requires a lot of patience, but learning LLM is amazing for your career. Now we will write the code for our project. I have created atlict's project folder here, and here you will find 2 files, requirement.txt and t-shirt sales Jupyter notebook. From here, I'm going to launch PyCharm Community Edition, which is a free editor for Python, and there you can open that particular folder. So I will go here, and in the C code directory, I will open atlict's project folder like that, and will not create any virtual environment. So I'll just say cancel. So there is no virtual environment, and let me pull this window right here. The first file we are going to create is main.py. Okay, and in this file we are going to create our LLM object. So now I will copy paste the code from our Jupyter notebook to here. We use Jupyter notebook for all our experimentation, and this is what data scientists do in when they're working for companies. They will do some experimentation in the notebook, and when they feel the code is ready, they will try to productionize it, and they will move it to a proper Python file structure or a project structure. So let's import all those libraries. So I'm just going to copy paste all the libraries that we imported in our Jupyter notebook. You can configure your Python here, and the first thing, if you remember, we were doing was creating a Google Palm object. Okay, so here I'm creating Google Palm object, and we need to give Google API key. Now in production code, you don't hard code your key here. The standard practice is to create environmental files, so .env, and you will keep your key here. Okay, so this is the key I have kept here. And how do I get this key from here to main.py? Well, we use this special Python module called .environment. From there we will import this method load this one, and when you execute this method, it will specifically look for .env file, and it will read the content, and it will set this as an environment variable. So this key will be environment variable, and this will be the value. Okay, so after this line, it has set the environment variable. Now how do I get the value of that environment? Well, you need OS module. So you will say os.environment, and in that the variable that we want is this particular thing, okay, and temperature is 0.1. I will not keep creativity very high, otherwise it will start bluffing, okay. And once LLM object is created, the next one is obviously the DB object, and the third one is our embedding, okay. And what I'm thinking is I will create a function which will encapsulate all this code. So let me put all this thing in a function here. All right, and here I'm going to copy paste all those things. So if you remember, we had embeddings, we had our vector database, and we have few short. So few short was an array, and I would like to put that array in a separate file. So I will call it few shots, and this file will contain all of this. Now answer I have hard coded, folks, because here we are giving this as an example to our LLM. That's see, this is the format of your answer. The exit answer it will get by executing this query. So that's something you need to keep in mind, and you can import that thing here. You can say from few shots import few shots, okay. So it will not give an error now. After example selector, I'll just copy paste all the code. So you're creating a exact same SQL database chain and returning it here. And we will create a main Python function. We'll say if it is main, this is how you create a main function in Python, by the way. And you will get this chain, and then you will run this chain, okay. You will say whatever is your query, and you will print the result. Okay, so what is my query? Well, let's just give some sample query to test. When you're doing this type of coding, it makes sense that you write some code and then test it. You write some code and test it. So here I will just run this and see, it gives the answer. And if you look at the query seems to be right. You can try different queries here, but let's say this is working. Now we are ready to write our Streamlit code. For Streamlit, I would like to keep the UI code in main.py, and I would move all the Langchain code in a separate file. I'll call it Langchain helper maybe. And let me just Control A, X, Control V. You know, Control C, Control V is the most powerful weapon for all programmers. And then here, I will import that method. Now let's do Streamlit coding. You will say import Streamlit as st.title. What is my title? Well, my title is this, and you'll have input box, right? So text input box, you will type a question here, and that question you will get here, and then if question, meaning if someone types in a question and they hit enter, the code flow will come here. First, let's taste this bear skeleton. So here in the terminal, you can run streamlit run main.py, and it will launch the UI in a browser. So see, my UI looks good. When I type a question, hit enter, it will take that question in this question variable, and the flow will come here. So here what we need to do, here we need to obviously first get a chain, and then we'll say chain.run, this is my question, and you get the answer. And then st.header, so you will put another element on the UI, and you will say st.write your answer. The good thing about Streamlit is that you don't have to rerun it from here. You can go here and just click on rerun. Now let's ask those questions. So I will hit enter here. See? Hooray! 3083. Let's ask a different question. And by the way, if you want to see a corresponding query, since we have set verbose parameter to be true, let's say you get 59 answer, you're not sure if it's right or wrong, you can either go to MySQL, run the query, or you can look at the query here. See, how many t-shirts do we have left for Nike and XS and white? See, Nike, XS, white, sum of stock quantity. This is perfect. And then yeah, so folks, you can ask different questions and get your answers. Now this tool will be very useful to our store manager Tony Sharma, because he will be able to ask questions directly and get answers on most of the questions.
That's it, folks. We are done with this Gen AI mini course. We also finished 2 end-to-end projects, which is something you can add in your resume. If you like this video, please give it a thumbs up and share it with your friends who wants to learn Gen AI. If you have any questions, there is a comment box below.